this joint is going to be a lap joint. It is a lap joint. This is a longitudinal joint. Longitudinal joint. They are in the short form of LJ. This is used to obtain required diameter of the shell. Used to obtain required diameter of the shell. Longitudinal joint. Generally this will be a butt joint. This is a butt joint and this is a lap joint. So every pressure vessel compulsory, which joint is a compulsory? Longitudinal joint is going to be there now. Consider this is going to be a sheet metal of length of L, width now. The length, width and thickness. Now I want to get a shell of diameter 1 meter. I want to get a shell of 1 diameter. Then what do you have to do it now? The sheet metal should be rolled. The sheet metal should be rolled based upon the required diameter. Based upon the required diameter, the sheet metal is rolled. And these two ends are kept side by side. So this here what now? This joint is what lengthwise is coming. Longer, but which dimension I am getting now? Diameter. If it is going for a longitudinal joint, is for the length. By using this joint, you are getting the diameter. So based upon the required diameter, the sheet metal is going to be rolled and the two ends are kept side by side. So this is called the one ring, you are going to call it. This is a one ring. It is a one ring. So it is giving a half meter diameter, length of 1 meter. But I need a pressure vessel length should be 2 meters. I need a pressure vessel should be 2 meters. Then what I have to do it now? This is one ring. Half meter diameter I am getting. 1 meter I am getting now. But I need a 2 meter. Then what I have to do it now? Similarly, one more ring should be fabricated. That is going to be overlapped here now. It will be overlapped. Then this joint is coming along the circumference. By using this joint, which dimension you are getting now? Length you are getting. But if it is what now? Circumference joint means they are going for a diameter. This is not giving the diameter. It is giving the required length. So longitudinal joint is to get the required diameter. Circumference joint is to get the required length of the shell. Now, here what type of, when you are coming to the stress analysis now, because this inside fluid is going to be there now, because the fluid pressure what happens now, length will increase. Because the fluid pressure, length will increase and diameter will increase. I am calling this a fluid force. Fluid force. Pressure into area. It is acting as a tensile force. So it will try to increase the length of the shell. It will push this shell towards left side, push towards right. Length will increase. Then this strain is going to be a tensile strain. It is called as what now? Longitudinal strain. Longitudinal strain. Always in a deformable member. In a deformable member. In a deformable member in the direction of the load, stress is there or strain is there or both are there. Both stress and strain are there. The relation between these two is given by Hooke's law. In a deformable member in the direction of the load, both stress and strain are there. The relation between is given by Hooke's law. So because this fluid force, what happens now? Length will increase. Then automatically the strain is a tensile. This strain you are calling as a longitudinal strain, tensile. And the corresponding stress is going to be a longitudinal stress. longitudinal stress, that is also tensile. Then at the pressure increase, what now? Diameter also increase, circumference also increase. So this also tensile strain, and this strain you are calling as what now? Circumferential strain or hoop strain. Circumferential or hoop strain. And the corresponding stress is called as what now? Hoop stress or circumferential stress. Now, the stress is variable or constant? Variable. Stress depend upon the fluid force. Fluid force depend upon the fluid pressure. But which one is the constant for a material now? Strength is a constant. Assume this is a mild steel. This shell is made of mild steel. Its ultimate strength is 400 megapascals. For mild steel, ultimate strength is 400 megapascals. SUT is 400 megapascals. For this one, I am assuming the SUT, mild steel. What is the meaning of this now? This material is able to withstand a maximum tensile stress of 400 megapascal without any bursting. But at the pressure increase, fluid force increase. At the fluid force increase, length will increase, longitudinal strain will increase, and longitudinal stress will increase. So at a particular pressure, whenever this longitudinal stress greater than 400, at the pressure increase, fluid force increases. At the fluid force increase, length will increase. Change in length is going to be increase. Then longitudinal strain will increase, longitudinal stress increases. Then at a particular value of the pressure, if this longitudinal stress greater than SUT, what happens now? This will push towards left side, push towards right side. Then bursting will get it what? Circumferentially. Due to longitudinal stress, push towards left side, push towards right. The bursting will occur circumferentially. So whenever the longitudinal stress greater than SUT, bursting will get it circumferentially. Next, as the pressure increases, diameter will increase. Change in diameter will increase. Then hoop strain increases, hoop stress increases. So once again, when this hoop stress is greater than SUT, what happens now? It will like this now. So what the dimension, the plane of the board now? What the dimension, the plane of the board? Length of the shell. So it will burst longitudinally. It will burst longitudinally. Otherwise, if I am going to show like this now, so it will burst longitudinally. So whenever the hoop stress is greater than SUT, bursting will get it longitudinally. When longitudinal stress greater than SUT, bursting of pressure vessel occurs circumferentially. That is what, like this, it will burst now. So bursting will occur. This is what now? This is a bursting circumference. This is due to increase in length or increase in diameter. This is due to increase in length. That is due to longitudinal stress. Similarly, if the hoop stress is greater than SUT, bursting occurs longitudinally. Bursting of pressure vessel occurs Bursting of pressure vessel occurs longitudinally. Longitudinally. What this figure representing now? Bursting of the pressure vessel longitudinally. But this is due to increase in diameter. That is due to increase in diameter means because of the hoop stress. And this is because of the longitudinal stress. Because of the longitudinal stress, bursting will occur circumferentially. And because of the hoop stress, bursting will occur longitudinally. It will what a burst longitudinal. This is due to increase in diameter. That is due to hoop stress, and this is due to increase in length, that is due to longitudinal stress. But which bursting will occur now? Which bursting will occur frequently? Whether bursting will occur longitudinally or circumferentially? This is why. Chance of bursting is more, or chance of bursting longitudinally is more, or bursting circumferentially more? Chance of bursting longitudinally more. Why? Always hoop stress is greater than longitudinal stress. Hoop stress greater than longitudinal stress. Hoop stress PD by 2T. Longitudinal stress PD by 4T. So as the pressure increases, which stress will reaches SUT first now? Hoop stress. So always what? This is the chance of failure will be more now. So more chance of failure of the pressure vessel. More chance of pressure vessel occur what? Longitudinally. Chance of failure of pressure vessel bursting longitudinally is more. So what the design engineer has to do it now? He has to design in such a way that there should not be any bursting longitudinally. When there is no bursting longitudinally, obviously there is no bursting circumferentially. So always design engineer has to design the pressure vessel such that is he has to provide the thickness in such a way that there should not be no bursting of the pressure vessel longitudinally. So you have to prevent this failure. Once you prevent this bursting now, automatically this bursting will not be there. So chance of, there are two possibilities of burstings will be there. One is circumferentially, one is longitudinally. But which bursting is more frequently occur? Not this one, because this is because of the hoop stress. So we have to design such that there should not be any bursting longitudinally. When there is no bursting longitudinally, obviously there is no bursting circumferentially. That's why this joint is made as about now. This joint is made as about now. Butt joint. Generally butt joint strength is more. Butt joint strength is more. And this is lap joint is used now. So generally the longitudinal joint is the butt joint. Because chancing of the bursting of the pressure vessel is more longitudinally. So you have to make this as a stronger joint than this now. That's why the longitudinal joint is always a butt joint. Circumference joint is going to be a lap joint. If I make the both as a butt joint, what happens now? Is uneconomical. Suppose this is going to be what? Both are lap joint, is unsafe. But if I am going to make this a lap joint, this is a butt joint, once again unsafe. So we want to get a safe and economic means this should be a butt joint and this should be a lap joint should be there. Always the butt joint strength is more than the lap joint. Butt joint strength is more than the lap joint. Double strap butt joint. Double strap butt joint is used now. Generally a standard question will be there now. Why the pressure longitudinal joint is made as a butt joint? Why longitudinal joint is a butt joint? Why not the circum joint is a butt joint? So you have to answer it properly now. Chance of bursting of the pressure vessel longitudinal is more. More chance of bursting will occur longitudinally. Hence, to prevent the chance of bursting of the pressure vessel longitudinally, that should be made as a stronger joint. So what this figure representing now? Bursting of the pressure vessel circumferentially. That is due to increase in length of the shell. That is due to longitudinal stress. This is what now fluid force. This push towards right side, push towards left side. So this is a cross section of the shell. So this is what the bursting of the pressure vessel circumferentially. What these two are representing now? Resisting areas. Resisting areas. what this areas now? Pi dt. Pi dt. Actual area is what now? Pi by 4 d naught square minus ds square. Since the thickness is less, it is taken as a pi dt. So this assumption is valid only in thin pressure vessel. This assumption is what not valid in the thick pressure vessel. When you go for a thick pressure vessel, what the area at write down now? Pi by 4 d square into 1 minus square square. This assumption is not the actual area. Actual area is what now? Pi by 4 d naught square minus ds square. So this is the assumption. This is valid what now? Pi by 4 d naught square minus ds square equal to pi dt, almost same when thickness is very small. So this assumption is not valid in the thick pressure vessels. So when I'm pushing like this, then resisting force is what now? Always what you have said, a resisting force develops similar to the load, opposite direction. Is the same concept of the just like an axial stress. So stress will be always in the direction of the load, in the direction of the resisting force. So this is about the stress. This stress you are calling as about a longitudinal stress. So longitudinal stress is just like an axial stress. Axial stress, what you have studied now? Perpendicular to cross section, that is in the direction of the polar axis, and it is a uniformly distributed. So longitudinal stress always in the direction of the polar axis. So this stress can be directly added to axial stress. Suppose if this pressure vessel is also subjected to some external axial load, suppose also subjected to external axial load, compressive load, then due to this one you are getting an axial stress. So which stress can be added now? Axial stress and longitudinal stress both can be added. Both are in the direction of the polar axis. Axial stress is compressive and longitudinal stress is tensile. So what the resultant normal stress now in the direction of the polar axis? Longitudinal stress minus sigma A. Suppose also subjected to bending. If it is also subjected to bending couple, due to bending couple you are getting what now? Top is a sagging. Then top you are going to get a compressive. Bottom is going to be a tensile. In that case, which one are the critical? Now bottom is a critical. Then what the resultant normal stress at the on the cross section of this now? Bending stress plus axial stress. But at the top, sigma L minus sigma B max. Longitudinal stress is tensile. But bending stress due to sagging is what? Top is a compressive. So what the resultant stress at the top? Sigma L minus sigma B max. Here sigma L plus sigma B max. So critical is what? The bottom will be there. So always the longitudinal stress can be added to either axial stress or bending stress both. So both are there. Compressive load is there and bending couple is there. Compressive load is there and bending couple is there. Then at that time what the resultant stress at the top now? Minus sigma A minus sigma B max and plus sigma L minus sigma A and sagging. Top is bending stress compressive. So which one the critical point here? Now minus sigma A minus sigma B max plus sigma L. Bottom will be what now? Minus sigma A plus sigma B max and plus sigma L will be there now. So you have to see what where the resultant stress is going to be more now. So remember what now? Always axial stress perpendicular to cross section, that is in the direction of the polar axis. So it can be directly added to either axial or bending stress. So this is similar to axial stress only. Axial stress uniformly distributed. It is also uniformly distributed. Most of the objective question they are giving only pressure. But one of the gate paper, gate question is given what now? Axial load, the tensile load is given, fluid pressure is given. Then due to axial load, you are going to get a tensile stress. Longitudinal stress also tensile. Then both can be added now. Now the sigma x or sigma y or sigma z. If I taken the polar axis x-axis, it is going to be sigma x. If the polar axis y-axis, it is a sigma y. So what is this figure representing now? Bursting of pressure vessel. That is the variable or constant, a variable when this value greater than SUT or when fluid force is greater than FR. When fluid force is greater than FR. But always you are dealing with the equilibrium. Now if I am assuming this is the x-axis, the polar axis, x-axis. So for static equilibrium equation, what you can write down now? For static equilibrium, by using the sum of the force along x direction is 0. Fluid force equal to resisting force. It is a uniformly distributed. When it is uniformly distributed, you can write down the what now? Average stress equal to F by A. Then F equal to average stress into area. How to write down the fluid force now? Pressure multiplied by area. Area of the shell. Pi by 4 d square. This is acting on the inner diameter. Pi by 4 d square. And what the resisting force now? Uniformly distributed. When stress uniformly distributed, sigma equal to average stress equal to F by A. F equal to sigma into A. So this Fr can be written as what a longitudinal stress multiplied by AD pi dt. Suppose the thick pressure vessel, then I have to go for what the area now? Pi by 4 d square into 1 minus k square. Now from this one we are getting a longitudinal stress is equal to PD by 40. PD by 40. But if the joint efficiency is given, but nowadays nowhere you are getting the joint efficiency because of welded joint. Welded joint have the 100% efficiency. But some of the old papers or some of the recent test series paper, they are giving the efficiencies. Efficiency. Once efficiency is given means obviously it is fabricated by riveted joint. But if the efficiency is given, which joint efficiency I have to take it now? This longitudinal stress developed because of the bursting of the pressure vessel circumferentially. So I have to go for the circumferential joint efficiency. If the joint efficiency is given, most of them are going for a longitudinal joint efficiency. Longitudinal joint. Longitudinal stress means they will take the longitudinal joint. Blindly remember reverse you have to take it. Why means this longitudinal stress developed because of the bursting of the pressure vessel circumferentially. So this much amount of what now? Resisting force is developed when you are having the 100% efficiency. This much of resisting force you are going to get when efficiency 100%. When efficiency less than 100%, you have to multiply by the efficiency of the this joint is which joint now? Circumferential joint now. Then you have to multiply by circumferential joint. Then longitudinal stress equal to PD by 40 into efficiency of circumferential joint. If nothing is given, you are going to assume the 100%. 100% now. This is what a bursting of the pressure vessel longitudinally. This is due to increase in diameter. Bursting of pressure vessel. When hoop stress greater than SUT, hoop stress greater than SUT. Here how many resting areas are there? No, 2. What this area? L and T. Backside also at LT. Here how many resting areas are there? 2 resisting areas. Then how many resisting force are there? No, 2. So here fluid force is pushing the shell downward. Resisting force will upward. Now hoop stress distributed over how much area? Longirus stress distributed over the circumference. Longirus stress distributed uniformly over how much area? Pi dt. But this hoop stress distributed what this area? LT. Similarly backside LT. Here how many resting force are there? No, 2. So when this bursting will get it now? When the fluid force is downward, resting force are upward. Whenever the fluid force is greater than the 2 FR, when the fluid force is greater than the 2 FR, this bursting will get it now. Now it is a biaxial or uniaxial state of stress now. Biaxial, why now? Hoop stress is developed over this LT. But longirus stress develop perpendicular to this now. This is what now? This is the area, circumference. This is which stress now? Longirus stress. Hoop stress and longirus stress are in 2 mutual perpendicular direction. So they cannot be added. But what about the axial and bending? Both are normal stress, but both are perpendicular cross section. So axial and bending stress can be added. But your hoop stress and longirus both are tensile, but both are in 2 perpendicular direction. They cannot be added. That's why it comes under biaxial state of stress. Biaxial state of stress. Here, how to get the equation now? Fluid force should be equated to 2 times the resisting force. So this is area is LT. So hoop stress is PD by 2T. But if the joint efficiency is given, we have to consider the longitudinal joint. But the resisting area LT, so hoop stress into LT. So here we are assuming the hoop stress uniformly distributed, but hoop stress not uniformly distributed. Hoop stress always more at the inner radius, minimum at the outer radius. Here assumption only. But since the thickness is less, we are assuming this assumption is justified. But if you go for a thick pressure vessel, this assumption is not valid. In the longitudinal stress calculation, what the assumption is taken now? Pi dt. That assumption is valid only thin now. If you go for a thick pressure vessel, we cannot take the pi dt. But here in this hoop stress calculation, once again you are assuming the hoop stress uniformly distributed. Longitudinal stress always uniformly distributed. Hoop stress not uniformly distributed. Hoop stress maximum at the inner radius, minimum at the outer radius. But since the thickness is less, the variation is neglected. But actual variation is about a hyperbolic. It is the maximum at the inner, minimum at the outer. So if you go for a thick pressure vessel, the variation is about hyperbolic variation. Always remember about hoop stress maximum at the inner radius, minimum at the outer radius. But since the thickness is less, that variation neglected, we are going for average stress now. So if you ask the joint efficiency, you have to go for the longitudinal joint. This is developed because of the bursting of the pressure vessel longitudinally. I'm showing the pictorial view for this bottom half, how we are getting this pressure into L into D. For this one, I'm drawing the pictorial view for the bottom half. So this is going to be the bottom half pictorial view now. So this is a resting area L into T. Hoop stress is perpendicular to this now. These are the resisting areas. What this dimension now? T. This dimension is D. These are going to be L into T. is the length of the shell. Length of the shell. Fluid force always perpendicular. This is a fluid force. Fluid force is perpendicular surface. Now this is fluid force. Then resisting force will be like this now. When fluid force is downward, then shell will offer the resisting force in this direction now. Which one the constant? Fr is the constant. Once a member is manufactured, what you studied, when a member is manufactured, Mr is constant, Tr is constant, Fr is constant. But this is varies. Load, resisting force is what a constant, but fluid force a load. This varies. This depends upon the pressure. So whenever this what now, at the pressure increase, this will increase. Whenever this greater than this 2 Fr, whenever this greater than 2 Fr, the bursting will get. That only I shown it now. Ff is greater than 2 Fr. Now stress will be always in which direction now? In the resisting force direction. Resisting force direction. And hoop stress is maximum here now. Maximum at the inner radius, minimum at the outer radius. Since the thickness is less, that variation you are neglecting. But this variation is considerable in case of thick pressure vessel. It varies hyperbolically. Always remember what a hoop stress is what now. That variations are shown in what now? Recorded lecture of the thick pressure vessels now. So this is going to be maximum here, minimum. It varies hyperbolically. But here we are assuming the uniformly distributed. Means at every point on the thickness of the shell, at every point you are assuming the same. Hoop stress. Since you are assuming the uniformly distributed, then how to find this resisting force now? Hoop stress multiplied by area. What this area LT? It is also LT. Therefore, what the total resisting force? 2 times the hoop stress into LT. And how to get this fluid force now? This force is what a distributed over how much area now? This area. This is what now? What this dimension now? This blue color hatched rectangle. The fluid force is distributed on the blue color hatched rectangle. This is D and this is L. What this blue color area now? This is L into D. This is what now? Projected area, you are going to call it now. The blue color area, L into D. That's why you are written about the pressure into L into D. So whenever this what a fluid force, how to get the fluid force? Now pressure multiply by L into D. So whenever this fluid force is greater than 2 FR, bursting will get it now. Now can you show the where the longirus stress? Longirus stress is like this. Longirus stress perpendicular cross section is the cross section of the shell. This marker will be what now? Longirus stress. So longirus stress and hoop stress are what? Both are normal. They are in the same direction or two perpendicular. This is the longirus stress. Like this now. If I am going to show like this now, this stress is what now? If I have shown like this now, this will be longirus stress and the hoop stress. What this dimension now? L into T. This now L into T. This is what now? Cross section. The cross section. If I am going to reverse like this now, this is a hoop stress, that's a longirus stress, and hoop stress is perpendicular this now. So both are in two mutual perpendicular direction. But what about the axial and bending? Axial and bending are perpendicular this now, directly can be added. This is a cross section of the shell. These are all what now? It is a uniformly distributed. It is a tensile or compressive. Tensile means it should be shown by dot. Tensile means it should be shown by dot. It is the longirus stress in the hoop stress. Both are two mutual perpendicular. That's why it is called as what now? Biaxial state of stress. Biaxial. But this stress is going to be axial stress perpendicular. Therefore, what now? Axial and longirus stress can be added. So blindly remember what now? Longirus stress always in the direction of the polar axis. So longirus stress can be added to either axial stress or bending stress. If this is clear, what a remaining is simple. Remaining is what a simply your principal stress chapter only. Now if I am going to consider a point here now, if I consider a point on the shell, strictly speaking, which point I have to consider? A point on the inner circumference, because hoop stress is maximum. But generally your thickness is less, you are going to consider any. Now I consider a point here now. How to define the state of stress? If I consider a small elemental cube, now this stress is which stress now? Longirus stress is a cross section. And what about this area? L and T. So this is what now? Hoop stress. And then one more stress is called about a radial stress. Once again, this is important radial stress. If I am going to show like this stress of which stress is the cross section of the shell. This is longitudinal stress. And this is what about this dimension now? LT. This is LT. This is hoop stress. Is a hoop stress, longirus stress. If I can show like this now. Otherwise, I am taking this half now. This half I am taking now. So this stress of which stress now? Is a cross section, longitudinal. And this stress is what now? Is a hoop stress. And this stress is a radial stress. This stress is a radial stress. If we consider with my hand now, like this now, is the pressure upward. P is upward. I'm considering a point on the shell. Now this will be which stress now? Radial stress. The pressure is upward, radial stress downward is a compressive. And what about this stress? Now longitudinal stress is a cross section, longitudinal stress. And what about this stress now? This stress is about now LT. It is a hoop stress. If I consider a point now, this is a pressure. It is a pressure, radial stress. If I taken the X, Z and Y, this stress is what is the cross section. This is longitudinal stress. Longitudinal stress in the direction of X. And this is Z direction hoop stress. And this is the Y direction radial stress. For equilibrium in the three direction, this is what a pressure upward, radial stress a compressive, longitudinal stress a tensile, and hoop stress also tensile. Out of the three stresses now, two are tensile, one is compressive. But radial stress equal to pressure. Radial stress equal to pressure. Thin pressure vessel means thickness is less, pressure is less, radial stress less. So we are going to assume the plane stress condition. What the plane stress condition you have studied now? One dimension should be small. Length is more than the diameter. Diameter is how many times the thickness? Now minimum 20 times. Thickness is small. So one dimension is very small. And what the next condition you are studying now? Loading should be in such a way that is what now? Pressure should be in such a way that the stresses develop in the smaller dimension direction. Here, which is the smaller dimension? This is the diameter. This is the length. Like this now. If I show like this now. This is what now? Pressure. Is the radial stress. Now radial stress coming along the thickness. And this is longitudinal stress distributed over the length. Hoop stress. And this is longitudinal stress. Longitudinal stress perpendicular to cross section. This is hoop stress, radial stress. Radial stress coming in the thickness direction. So what the second condition here, sir, plane stress now? Loading should be in such a way that the pressure should be in such a way that the stresses develop in the smaller dimension should be smaller in comparison to stresses develop in the larger dimension. Therefore, here radial stress equal to pressure. Since the thickness is less, pressure is less. When the pressure is less, radial stress is less. So radial stress magnitude is smaller in comparison to hoop and longitudinal stress. That's why radial stress neglected. But if you go for a thick pressure vessel, thickness is more. Then pressure is more. Radial stress is more. Then radial stress cannot be neglected. So always the pressure vessel, what type of state of stress is there now? Pressure vessel, you are going to get the what now? Triaxial state of stress. But in thin pressure vessel, it is assumed as a biaxial state of stress. Since the thickness is less, pressure is less. When the pressure is less, radial stress is less. Radial stress neglected, it is assumed as a biaxial state of stress. But if you go for a thick pressure vessel, radial stress cannot be neglected. It is a constable. Radial stress always equal to pressure. Thickness is more means pressure is more. When the pressure is more means radial stress is more. In that case, hoop stress, radial stress, longitudinal stress, all are going to be constable. So thick pressure vessels are going to be triaxial state of stress. So what the difference in the thin and thick pressure vessels now? Thick pressure vessel D by T ratio less than 20. Thin pressure vessel is D by T is what greater than 20. In thick pressure vessel, area should be taken as pi by 4 d square into 1 minus k square. Thin pressure vessel area is taken as pi dt. In thick pressure vessel, hoop stress is hyperbolically distributed. It is maximum at the inner radius, minimum at the outer radius. But thin pressure vessel thickness is less. It is assumed as a uniformly distributed. Next, in thick pressure vessel, radial stress cannot be neglected because pressure is constable. But in thin pressure vessel, radial stress is neglected because pressure is less. And last one is thick pressure vessels are triaxial state of stress. But thin pressure vessels can be assumed as a plane stress condition. Plane stress condition, that the biaxial state of stress condition. This will be equal to pressure. This is how much you got it now? PD by 40. This is PD by 2T. PD by 2T. Just now shown with my hand. This is what a part of a pressure vessel, or just with workbook I explain now. So this only I am showing now. Then for proper understanding, still some students are unable to visualize this hoop and longitudinal radial stress. Most of the textbook they will show only hoop and longitudinal. They will not show the radial thin pressure vessel. If the radial stress is not clear, then thick pressure vessels are not going to be clear now. So just now what I explained with my hand is a part of a pressure vessel. This is what the part of a pressure vessel. This is what the longitudinal axis. These are taken XX. So this only called as what? For cross, this is a cross section, polar axis. Is a point. This is Z I am taking. Is Y. This will be the pressure. Pressure will be in the radial direction, that is Y direction. Now this will be the for equilibrium. For equilibrium of the force in Y direction. This stress is about now. So radial stress equal to pressure. And by considering the equilibrium of the force in X direction, we got the longitudinal stress. And this Z axis, what this area L into T is L and T. This is what the LT. Longitudinal stress, what now? Hoop, longitudinal stress perpendicular to cross section. Hoop stress perpendicular to which area? LT. This is long hoop stress. Hoop stress. Now directly these are the principal stress. No shear stress. Directly these are the principal stress. Is a sigma 1, sigma 2, sigma 3. If you neglect this one, sigma 1 and sigma 2. Now you have to consider small elemental cube such that that cube is perpendicular to all these three axes now. Always what you have said now. we have to consider when you have discussed the stress tensor, you have to consider a point in such that, we have to consider a cube such that this cube should be considered around this point. Now what the three faces of this cube? What this dot now? Point. So this is what now X face, Y face, Z face. Now this cube is taken outside. The cube is taken outside. So directly these are the principal planes. Principal planes. Now this will be taken as sigma 1. Is a sigma 2. Sigma 3. Now for thin pressure well always these are very small, so it is neglected. If you take the any numerical data, you can take it now. Check it, this is very small now. Suppose this is 500, this is 250, this will be 5 or 10 megapascal will be there now. This is 500, this is 250, this will be some 5 or 10 megapascals you are going to get it now. So this is very small, it is neglected. That only you have studied now. Plane stress condition you have studied now. So by neglecting radial stress very small in comparison to hoop and longirus stress. Hence radial stress neglected. Then biaxial state of stress is considered. Biaxial state of stress is considered. If this is clear now, remaining is what a very simple, simply principal stress chapter only. If this you can understand, most of them are unable to visualize radial stress. Know that every student asks the equation, they will give hoop stress PD by 2T, longirus stress PD by 4T. They will give it now. But they don't know how they are developed and what is the radial stress. If this is not clear, we cannot, thick pressure vessel will not be clear now. So every chapter some assumptions. Here assumptions are what now? Thin pressure vessel assumptions are first d by t is greater than 20, area is taken pi dt, hoop stress assumed to be uniformly distributed, then radial stress neglected, and biaxial state of stress is considered. Biaxial state of stress is considered. Now whatever the equation I am writing, this all you can directly write down now. You need not remember any of this thing. Thin cylindrical pressure vessel under internal pressure. Now this is assumed or actual now, assumed. This stress will be about a radial stress. What this marker now? Radial. That is neglected. This is the assumed state of stress. What is the meaning of assume means radial stress neglected, biaxial. Actually the triaxial will be there now. So remaining directly can write down now. These are the principal plane. You can see now completely every chapter is what now? Linked with the principal stress chapter now. Now this is sigma 2, this will be a sigma 1. Now whatever the equation I am writing now, all this equation directly can write down without remembering any of this thing now. So what the sigma 1 hoop stress PD by 2T sigma 2 here which theories are going to give about the theories of failure are compulsory, but sigma 1 sigma 2 like or unlike now, like in this case what happens now, MPST MSST strength criterion will give the same results. That fine, all the textbook they are in the strength criterion. Everybody is going to contradict now how we are in the strength criterion and biaxial. Here is a biaxial only. Principles are like or unlike in nature, like in nature. Check your my conclusion now. In this case, maximum principal stress theory, shells are generally what a ductile material. Then why you are in the MPST? Actually you have to use the MSST. But here MPST, MSST and strength criterion will give the same results. So what the equation now? Sigma 1 less than or equal to sigma T permissible. Sigma 1 less than or equal to sigma T permissible means is the MPST, MSST and strength criterion. When the principles are like in nature, what the MSST are written now? Sigma 1 less than or equal to, when sigma 1 and sigma 2 are what now? Like in nature, what the absolute tau max is written as sigma 1 by 2. So in this case what now? Theories of failure are what now? Compulsory, but MPST, MSST and strength criterion will give the more safe. But if you want to get a economic, safe and economic, you have to go for MDT. Otherwise, generally in all the textbooks we are bothered about only safety. When you are bothered about safety, only you have to go for MPST, MSST and strength criterion. Sigma 3 0. Then absolute tau max. Absolute tau max. Principles are like in nature. When the principles are like in nature, what the absolute tau max? Sigma 1 by 2. PD by 40. And what the in plane tau max? PD by 80. Next, plane stress condition. Plane stress condition. Epsilon 1, major principal strain. How to write down now? 1 by E major principal strain or hoop strain equal to 1 by E sigma 1 minus mu sigma 2, which is equal to, how to write down the hoop strain? Delta D by D. Delta D by D. What the sigma 1? But what the sigma 1? PD by 2T. These equations are known to every student now. But some students are by heart it now. There is no need to by heart it now. Only if you know remaining all you can write down now. Now this is an expression for major principal strain or hoop strain. If you ask about the change in diameter, next epsilon 2 minor principal strain, nothing but the longitudinal strain. If you have the change in length, but if you have the change in thickness, how to find out the change in thickness? Now epsilon 3 equal to delta T by T. That is called the radial strain. Radial strain epsilon 3. Radial strain 1 by E sigma 3 0. From this one we can find out the change in thickness. Radial strain epsilon 3. Biaxial state of stress, what you have studied now? State of stress is a biaxial, but state of strain is not a biaxial, triaxial, because the what? No? So many times you mentioned now, except in case of Cork, under plane stress condition will not get a plane strain. Stress is state of stress is a biaxial, but state of strain is a triaxial, because that lateral strain concept you have studied now. Now from this one you can find out the change in thickness. Sigma 1 plus sigma 2, this is what now? Sigma 2 is sigma 1 by 2, therefore 3 sigma 1 by 2 will be there now. Thickness is going to be decreased. What the sigma 1 now? PD by 2T. So what the thickness expression now? Change in thickness. Now similarly, what the volumetric strain? What the volumetric strain you have studied now? Longer strain plus 2 times the hoop strain. Longer strain plus 2 times the hoop strain. Now you can substitute this now. You can substitute these two equations here now. Change in volume of the shell by virginal volume. This will be phi minus 4 mu. Phi minus 4 mu. Next, spherical. What about the sphere now? Sphere is a symmetrical object. Sphere you are going to get only diameter will be there. There is no length. Then only which strain is there now? Circumferential strain is there. Circumferential strain. Then you are getting only circumferential stress. There is no longer stress. Sphere is a symmetrical object. So directly I am writing for sphere now. Thin spherical pressure vessel under internal pressure. Sphere is a symmetrical object. You will get only hoop stress. Both the direction will get only hoop stress. So in this case, sigma 1, sigma 2 are equal to hoop stress. But here same thing, how we are done it now for cylindrical. If we are going to take a sphere, this will be PD by 40. In this case, principal stress are equal and like. In this case, what happens now? MPST, MSST, MDET, strength criterion will give the same results. In this case, MPST, MSST, strength criterion will give same results. Here MPST, MSST, MDET, strength criterion will give same results. If you ask to determine the safe and economic, everybody is going for MDT, but all are going to give the same results now. MPST, MSST, MDT, strength criterion will give the same results. All are going to be what now? Safe and economic. Sigma 3, 0. Here you are going to get only one strain. That is epsilon 1, epsilon 2 are equal. So from this one, but sigma 1 and sigma 2 are same. Here sigma 1, sigma 2 are same. But if you ask that change in diameter, same thing, if you ask to find out the radial strain, I am not writing now. You want to find out the radial strain, same, you can do it now. Radial strain and what the volumetric strain here now? 3 times the hoop strain. Three PD upon 40 into 1 minus mu. 3 PD upon 40 into 1 minus mu. कोई भी डायरेक्शन ले सकते हैं इधर. This is X phase, this is Z phase, this is Y phase. X, Z and Y. Pritam Jyoti. So the questions directly can do it now. Some students, some teachers, they will give only final equation this now. Then in that case, the chapter can be completed within half an hour or 1 hour, you can complete it now. But they don't know what is the radial stress. If the radial stress is not clear, they don't know what the thick pressure vessels also not clear now. Simply remember the equations. All these equations directly can write down. If you are thorough with principal stress chapter now, only you should know hoop stress and longitudinal PD by 2T, PD by 4T. Here both are going to be same. Sphere is a symmetrical object, PD by 4T. If you cut a sphere, what now, horizontal or vertical, you are going to the same area. If a cylinder, you cut it horizontally, what you are getting LT. If you cut it what now, vertically, you are getting what now, cross section pi dt. If you cut the cylinder horizontally, you are getting what, you are getting area is LT, but sphere you cut it horizontal or vertically, what the area pi dt are going to be there now. Expression for the thickness of the shell. CA means corrosion allowance. Some of the pressure vessels are operating in a corrosive atmosphere, corrosive atmospheres. Then at that time you have to add the corrosion allowance. If the corrosion allowance is not given, only in one of the engineering service paper is given. I'm writing a generalized. If it is not given, 0. If the efficiency is not given, 100%, efficiency of longitudinal joint, but I have written J. Here you are going to get only one joint will be there now. Spherical pressure vessel, you are getting only one joint, that is the circumferential joint. There is no longitudinal joint. So simply I called it a joint only. Here only one joint is there. Spherical pressure vessel, you are getting one joint, that is the what now? Circumferential joint, or otherwise, what the circumferential joint will be there now. But here two joints are there. So simply I use a joint efficiency. If the joint efficiency is not given, you have to go for 100%. If efficiency is, corrosion allowance is not given, you have to go for 0. But this is by using MPST, MSST strength criterion. So it is going to give the more safe. But if you ask safe and economic, if you ask the safe and economic, then you have to go for MDET. What the MDET equation now? Sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 less than or equal to sigma t permissible whole square. And that thickness will be less than this thickness. You will get it now, less than this thickness. But this is what by using this thickness itself safe and economic, because MPST, MSST, MDET all are going to give the same result. So sometime if you ask what now, find out the safe and economic thickness of a spherical pressure vessel. This itself safe and economic. But here safe and economic means you have to go for MDET. Otherwise simply thickness means you are using this only, because in all the textbook they are going for more safe now, more safe, then you have to go for this only. So in the workbook, chapter number 9, time being, those who are preparing only gate, you can do only thin pressure vessel questions. Out of the around 35 questions, 23 questions are from thin pressure vessels. Around 10 or 12 questions are thick pressure vessels. So those who are preparing for only ESC, the thick pressure vessel lecture will be uploaded by tomorrow. Tomorrow it will be uploaded. You can check it, and that is a 1 hour lecture, that's all. 1 hour lecture is there now, because all the basics are required now. You can easily, what the difference also I discussed now. Only the variations, hyperbolic variations, that I can go through that lecture. But those who are preparing for gate also, if you want, you can go through that lecture, it's up to you. But as per the syllabus, thick pressure vessels are not there in the gate, only thin pressure vessels are there. Now only one question, some concept is required. That question I am going to discuss, then we'll come to the thermal stresses. This is also concept oriented. Chapter number 9. I not remember exactly, maybe question number 10 or 11. Question number 10 or 11 will be there. It is one of the very old paper, old civil engineering paper. This question from the Timoshenko Gere now. It is given like this. And same question almost after 10 years, maybe 15 years, the same question given in gate mechanical. It is given like this. So far you have studied only pressure, but is also subjected to axial compressive load. I have explained this now. And it asks, determine the force F. Determine the expression for the F, that is the axial compressive load, in terms of P to obtain a pure shear state of stress. Expression for F in terms of P to obtain pure shear state of stress. What is the meaning of pure shear state of stress? Sigma x plus sigma y should be 0. When only fluid pressure is there, what happens now? When only fluid pressure, what the sigma x plus sigma y? 3 PD by 40. Sigma x is what? Longer stress, PD by 40. Sigma y is PD by 2t. So what the sigma x plus sigma y? 3 PD by 40. So who knows this pure shear state of stress? They done it now. So that is indirectly what is asking now. Sigma x plus sigma y should be 0. You can directly do it now. Which stress can be added now? Longitudinal stress and hoops. Longitudinal stress and axial stress can be added. So what the axial? What about the sigma x now? Axial stress plus longitudinal stress. Sigma L but what the longitudinal stress? PD by 40. But axial stress is a compressive. And what the hoop stress? PD by 2t. 0 means F by pi dt 3 PD by 40. That's all. Only 1 minute you can do it now. Always what you have studied now. Longitudinal stress and axial stress can be added. Axial and longitudinal stress can be added. But one is a tensile, this is a compressive. So if you apply this much amount of axial compressive load, then what the meaning now? Pure shear means maximum tensile, maximum compressive. Maximum tensile, maximum compressive, maximum shear stress, all are equal. Under pure shear, what you have studied now? Maximum tensile, maximum compressive, maximum shear stress, all are going to be equal in magnitude. If you want to get the explanation, what you can do it now? Superposition. When only fluid pressure is there, when only fluid pressure is there, this is a state of stress. It is not a pure shear. Summation will not be 0. Next, when only axial compressive load is there. Axial compressive load means what now? Uniaxial state of stress. Axial compressive load is there alone. Then both are acting simultaneously. So what the resultant state of stress? So what this line is representing now, cross section. Always longitudinal stress perpendicular to cross section. Axial stress also perpendicular cross section, polar axis. This is state of stress due to pressure as well as axial compressive load. Now you can do all these questions now. This is only one concept oriented. But if a student who don't know the pure shear state of stress, he cannot complete this question. Some question clearly mention they are concept oriented. Concept oriented. If a student, he don't know what is the pure shear state of, he cannot complete the question. He cannot complete the question. Remaining questions, you can directly do it now. So right on the next topic, thermal stresses. Okay, now. All the topics are took more time when compared to other batch now. This topic is generally completed with 1.5 hours now. And theories of failure generally 3.5 hours. But your batch it is taken almost 4.5 hours you taken now. If you are studying, you have to study 100% perfectly. Simply completion of the syllabus, doing the questions without understanding the concept, there is no use now. So my intention is only, if I am going to cover anything, that should be covered effectively. Only simply completing the syllabus, doing the workbook questions, if we leave it, there is, I will not be satisfied because my students are not going to be satisfied now. My students are satisfied, definitely I am going to be satisfied. But definitely 10 or 30% need only that type of coaching only. They need only problems, only equations. In that case, you will not get a success in the GATE and ESC. That approach is required for university examination. Already subtracted, no, here, my dear friend. Sigma L minus sigma I means what? Subtracted only, no? I kept it minus and I kept it now. Axial says what? A compress, that's why I kept the minus and I kept it. It is a subtraction or not now? Who is asking the doubt after seeing also? Abhiday Sharma, check it what now? What you have written now? Is it a subtraction or not? And here also you can see it now, same. Okay. So we'll come to the thermal stresses. So far, whatever the stress you have studied as what a mechanical stresses. So far, whatever you have studied the mechanical stresses, that is due to loads acting on the cross section. That is a axial stress, bending stress, torsional, direct shear. They're all due to externally applied force. And you assume the temperature is constant. So the stresses developed due to externally applied forces and the couples are called the mechanical stresses. And what the assumption you made so far now? Temperature is a constant. Temperature is a constant. We assume the temperature is a constant, means we are not considered any deformation due to change in temperature. Now we are going to study due to change in temperature. So once I am mentioning now, so far whatever you have studied, they are all called the mechanical stress. Mechanical stress are those stresses which are developed due to externally applied forces and the couples. And we assume the temperature is a constant. Now you are going to study if the due to change in temperature, how to find out the stress strain deformation. They are the thermal stress. Here we are assuming only change in temperature. So far you assume only loads are acting, temperature a constant. So far you are not considered any thermal deformation. When there is no change in temperature, there is no thermal deformation, no thermal stress. But here considering change in temperature alone, then at that time when the temperature increases, expansion will be there. When temperature decreases, contraction will be there. And when the thermal stress is developed now, if the thermal stress should be developed, there should be a two condition. First condition is what? There should be a change in temperature. Because of that change in temperature, either thermal expansion or thermal contraction. That's the first condition. Then second condition is that thermal deformation should be restricted either completely or partially. That thermal deformation should be restricted either completely or partially. If only change in temperature is there, then you are having only thermal deformation, thermal strain. Stress is zero. What you have studied, whenever stress should be there should be a load should be there. So what the condition for thermal stress now? If thermal stress should be developed, first condition is what now? There should be a change in temperature. Next, the second condition is what now? The deformation, thermal deformation should be restricted either completely or partially. In this example, if this rectangular block, as in the rectangular block kept on a flat surface, is heated, then length will increase, height will increase, width will increase. In this case, only thermal change in length is there, change in height is there, change in width is there. Then thermal strain is there, thermal deform, but thermal stress zero. Whenever you want to get a stress in the direction, there should be a load. There is no load in all the directions. Therefore, this is called as what now? Free expansion. So in this case, only you have to study the which case is the case 1. In this case, you have to study the expression for change in dimensions and strain, thermal strain. But there is no stress. This is the first case. Second case is what like this now. If this duster is kept like this now, kept between two supports, if the temperature increases, bar will tries to expand, but my two hands are restricting. My two hands are restricting. If the temperature in the right side, this will tries to expand the right side, but my hand is restricting. When this temperature in this will what now? This right hand side of the bar will tries to expand towards right side. Mean what the action of this end of the bar? What the action of the end of the bar onto my hand? It will push my hand towards right side, but my hand will offer a reaction towards left side. Then this is going to be about a compressive load. Then similarly, what this end of the bar, left side of the bar will tries to expand towards left side. So what the action of this bar now? Action of the bar towards left side. Then reaction will be towards left side, so towards right side. So then is about now. So in this case, deformation is restricted. Deformation restricted how many direction now? Lengthwise or heightwise now? If I am taking the x direction, y and z, deformation restricted only one direction. So stress is developed only one direction. This is a uniaxial state of stress. But what about the other two directions? Stress is zero. Other two directions, stress is zero, but strain is there. So this is what now? Completely restricted expansion in one direction. Then it comes under uniaxial state of stress. Now how many strains are in this direction now? How many strains are there? Two strains. One is due to change in temperature, that is the thermal strain. And one strain is due to longitudinal strain. In x direction, how many strains are there? Two. Due to change in temperature, increase in length. And due to reaction, contraction in the length. So the strain due to reactions is called the longitudinal strain. And due to change in temperature, thermal strain. Thermal strain is the tensile and longitudinal strain is the compressive. You have to do the superposition. This should be taken as what now? Superposition. First you remove this hands. If you remove this hand, will become as what now? Free expansion. Free expansion. Next, assume only axial load acting alone. It is a uniaxial state of stress. Then you are getting one longitudinal, two lateral strains. So in this case, how many strains are there? X direction one thermal, Y direction one thermal, Z direction one thermal. But when reactions are acting alone, what happens now? What the strain in this direction? A longitudinal strain and lateral strain. Then you have to superimpose. So now, when both are acting, change in temperature is there and reactions are there. In this case, how many strains are x direction or two? One thermal strain, one longitudinal strain. Net strain is zero. Net strain is zero. Y and Z direction due to change in temperature thermal and due to reaction lateral strain. So other two direction you are getting two strains. One is the thermal and one lateral strain. Simply superimpose it. Now if I am going to restrict it three directions now. This restricted in three directions. What happens now? Reactions are developed in how many directions now? Y, X and Z. So the triaxial state of stress. Triaxial. Sigma X, Sigma Y, Sigma Z. Sigma X, Sigma Y, Sigma. Then how many strains are there? Under triaxial, how many strains are there? X direction 3. Longitude, when you are studying the volumetric strain. X direction, how many strains are there? When you derive the equation for volumetric strain, first you assume the Rx acting alone. One longitude, two lateral. Ry acting alone. One longitude, two lateral. Next Rz acting alone. One longitude, two lateral. And change in temperature there. So each direction, what if only Rx is there? Rx and Ry, Rz. So each direction, how many strains? 3. One longitudinal, two lateral. Then change in temperature thermal. That only I written what when you derive the expression for volumetric strain. What the total strain you have written now? 1 by E sigma x minus mu sigma y plus sigma z plus thermal strain alpha T are written now. Thermal strain. So here is restricted in three direction. Rx, Ry, Rz and change in temperature. So each direction how many strains are there now? 4. What are they now? Due to Rx longitudinal strain. Due to Ry x direction lateral. Due to Rz one lateral. And due to change in temperature one thermal strain. So total how many strains are there now? 16 strains are going to be there now. Sorry, not 16. 12 strains are going to be there now. What are the 12 strains? 3 longitudinal strain, 6 lateral strain and 3 thermal strain. Try to recollect it what you have studied in the volumetric strain. Now to find out this reaction here now. How to find out this reaction? How to find out the stress in this direction? Equate the total strain x direction to 0. What the total strain now? 1 by E. How many unknowns are there now? Sigma x, sigma y, sigma z. 3 unknowns. How to find out the 3 unknowns? By using the 3 equation. What are the 3 equation now? Epsilon x is equal to 0, epsilon y is equal to 0, epsilon z is equal to 0. What the epsilon x? 1 by E sigma x minus mu sigma y plus sigma z plus alpha t, thermal strain. Next, epsilon y equal to 0. 1 by E sigma y minus mu sigma x plus sigma z plus alpha t equal to 0. Same thing, epsilon z. 1 by E sigma z minus mu sigma x plus sigma y plus alpha t. Try to check it. What is it? I already written in the what now? Volumetric strain I written now. So this is only, this case should be thorough now. If you know this case, remaining all are superposition. This is what now? This only one case I have to explain now. That is how to find out the change in length, change in width, change in height due to change in temperature. Then you have to write down the strain. Then you have to write down the expression for volumetric strain. If this is clear, remaining is what? A superposition. This is one case you have to study. If this is clear, remaining all are superposition. You can do it now. So this is a combination of what now? Is a combination of free expansion and axial load acting alone. Free expansion, then axial load, compressive load alone. Next, this is what a combination of, if I remove this my hand, it will become as a free expansion. Then we are assuming that my hands are acting now. Rx, Ry, Rz. This is a combination of free expansion as well as what now? Triaxial state of stress. Free expansion and triaxial state of stress. Then you can do it now. Only the student should be thorough with the what now? Free expansion case. Free expansion case should be thorough now. Next, thermal stress always about now normal stress. Why? When the thermal stress develop now, when deformation is restricted, which force are restrict the thermal deformation now? Normal load or shear load? Change in length should be restricted means what? You have to apply a compressive load. Is a normal load. Due to change in temperature, what happens? Dimensions are going to be changed. So if we restrict that change in dimension, stress is there. So if we want to restrict that change in dimension, you have to apply a normal load or shear load, normal load. Therefore, always a thermal stress and normal stress. Always a thermal stress and normal stress. Maybe a tensile or compressive. Thermal stress always a normal stress, maybe a tensile or compressive. So this thermal stress should be added to which mechanical stress? How many mechanical stress you have studied in the cross section? How many mechanical stress you have studied in the cross section? 4 stresses. What are they now? Axial, bending, torsional shear and direct shear. So the thermal stress should be added to directly what now? Either axial and bending. Thermal stress can be directly added to the axial and bending. If thermal stress is tensile, axial stress also tensile, you can add it. Thermal stress is compressive, axial stress is tensile. Then plus axial stress minus thermal stress you have to take it. But due to externally applied load, I am getting a twisting couple. Like this now. Here twisting couple is applied. And change in temperature is there. So due to twisting couple, which stress is there now? Torsional shear stress. And due to change in temperature, you are getting a compressive. So on the cross section, how many stress are there now? One compressive stress and one shear stress. So this compressive stress due to thermal. and shear is due to twisting, then it comes under what now? Combined stress. Then you have to use the theories of failure concept is required. Principal stress chapter is required. So remember what now? Thermal stress to be always added to axial and bending. Directly can added. But in one of the very old gate paper, this question is given now. This question. A bar is fixed at both the ends. And at the middle, at the junction, a twisting couple is applied. Twisting couple is applied. And change in temperature is there. Then due to change in temperature, what happens now? Thermal stress. Thermal stress is compressive. If temperature increases, thermal stress is compressive. And due to change in temperature, torsional shear stress. So on the cross section, you are getting a what now? One compressive stress and one shear stress. Then you have to do the principal stress and ask what now? Find out the diameter of the bar by using the distortion energy theory. How to find out the diameter now? By using the distortion energy theory. Sigma 1 square plus directly can use which equation? Now, sigma t permissible equation. But the sigma t permissible equation as per MDET, square root of sigma x square plus 3 tau xy square. What the sigma x? Thermal stress. And tau xy is what? 16 t by pi cube. Subject is completely interrelated, but most of students they left it now. But in the workbook, what you are doing now? First chapter only thermal stress, and chapter number 6 only torsion. But they combined this question now. But most of students what now? They struggled it now. So remember what? Always a thermal stress is a normal stress. So thermal stress should be added to directly either axial and bending. Suppose the same question now. At the here middle, a bending couple is applied. One eccentric axial load, one eccentric. Therefore, you are getting a bending couple. Bending couple is there. So this is what a bending couple is what now? Then you are going to get a bending stress is going to be there. Bending stress is normal stress. Bending stress is always axial stress. So bending stress can be directly added to the thermal stress. We don't need the principal stresses now. Directly can add it, and we don't need theories of failure. Directly can use your strength criterion can be used it now. Total normal stress. On the cross section. Mechanical stress. Mechanical stress. Always a thermal stress about now. Always a thermal stress is a normal stress. Means maybe a tensile or compressive will be there. But what about the mechanical stress? How many mechanical stress are there now? On a cross section. Axial, bending, torsional, shear and direction. But I am adding. Thermal stress and normal stress. I am adding means obviously it should be a normal stress. So this should be about either axial or But this question just now explained now. So in this case, what happens now? Due to change temperature increase, it will expand. But expansion is permitted or restricted? Restricted. Then you are going to get a one axial compressive load. Then how many reactions here now? Due to this twisting couple, what the reaction now? TB. TA. So these reactions are what? Due to twisting couple. And due to change in temperature, what you are getting now? So due to this R, what you are getting now? Compressive stress. That is the thermal stress. And due to this twisting couple, you already, suppose I remove this change in temperature, this question already had done it now. If the change in temperature is 0, then these reactions are 0. Then this question already done it now. How to find out the reaction? T into multiply by distance by other end upon total length. Suppose this distance L by 4, this 3L by 4. What this TA now? 3T by 4. And this reaction T by 4. Then you know how to find out the maximum torsional shear stress. If this is L by 4, this is 3L by 4. So what the TA value? No, 3T by 4. And this is T by 4. What the maximum torque? No, 3T by 4. So what is this reaction now? 3T by 4. So you are going to get it what? What the sigma x now? Thermal stress. This you are going to study now how we got thermal stress equation is this now. If this question is going to be done by a student, means what? Is thorough with the entire subject now. Then tau xy. What is the maximum torque now? 3T by 4. So it is now can you add these two now? We cannot add it now. It's a combined stress. Then what is the state of stress now? That's all. Now you can find out the principal stress. Then what is the ask now? Diameter of the bar by using distortion energy theory. How to find out now? We can use the which method I have to use it? Now third method. Only sigma x is there, sigma y 0. So what is the sigma t permissible as per MDET? Sigma x square plus. So you can find out the diameter can be calculated now. If the change in temperature is 0, change in temperature 0 means what? The sigma x 0. This will become as a pure torsion. Then in that case, theories of failure are optional. Directly can use the torsion equation. But here, theories of failure are compulsory because of combined stress. But in the question is asked, find out the diameter by using MDET. Only can use the third method. Directly third method is what now? Principal stress also not required now. What the sigma x now? Sigma x means minus alpha delta TE. And tau xy is what? 12T by pi d cube. Find out the diameter. So by chance a bending couple, now you can add it now. If you add a bending, if only bending couple is there, what happens now? Bending stress and thermal stress both can be added. Recently I added this question now. Previously I not used to discuss now. This year only added now. Because when I last year wrote now, during the GATE exam, maybe they asked me what prepare the questions of RTQ, revision through questions. Then at that time, I had to discuss some questions which are not discussed in the class. So when I'm going through the what now, I'm seeing the what now. I got a what now, old mechanical GATE paper book now. That is when I prepared it. When I appeared for my GATE in 1991, I appeared now. At that time, I found one book now. So in that one, this question was there now. So that question what now? There is no concept, new concept is not there. But you have to use the concept of what now? In this chapter, you are studying only this now. So far what? In the torsion chapter, you assume that temperature are 0. Temperature 0. And in the thermal stress chapter, you are assuming only change in temperature. There is no twisting couple. So the combination of what now? Thermal stress as well as the chapter number 6 is going to be there now. Who has followed what now? Who has followed who is thorough with the concept, they done it now. So we should know what always the thermal stress and normal stress should be known now. Sometimes the MSQ will be there now. Which of the statements are going to be thermal stress is tensile stress, compressive stress, shear stress, all of the above. What the answer now? If the MSQ means both tensile and compressive. Thermal stress and normal stress, maybe a tensile or maybe compressive, but never thermal stress is going to be a shear stress. Thermal stress develop when the deformation restricted. So to restrict the deformation, you have to apply normal load. Condition for thermal stress. Only this you have to do it now. Most of students already known, but you are going to do it how we got it now. Anybody about how we got this equation now? How we got this change in length is 0. Due to change in temperature, increase in length is there. How we got this equation now? By equating change in length to 0. For the change in length due to change in temperature. For the change in length due to change in temperature, alpha delta TL. Alpha delta TL. This is a change in length. Increase in length due to change in temperature. And what the decrease in length due to reaction? These reactions are acting as axial load. So it is RL by AE. 0. Delta L equated to 0. So what this R by A? Stress. So this only are calling as a thermal stress. Change in length 0 or non-zero? Change in length is non-zero. How many change in lengths are due to change in temperature? Temperature increase, length will increase. So this is a thermal deformation, alpha delta TL. Next, when reactions are acting alone, how the reactions are acting alone? No, axial compressive load. What the change in length due to axial compressive load? PL by AE. But what the axial load? Minus R. Minus RL by AE. So from this one, what the thermal stress equation? No? Alpha delta TE. completely basic. Only you should know this equation. Only this equation. This equation you are going to get what now? If you know this equation, remaining all you can do it now. That is only what a free expansion should be thorough now. If you know this one, only how you got the equation is known. This equation is known. Only you should know this equation. If you know this equation, this is what now? Free expansion. If I am going to remove the what now? If I remove this R, supports are restricted, supports are removed, twisting couple is removed, only change in temperature is there. It is a free expansion. The increase in length is alpha delta TL. Due to twisting couple, now, there is no change in length now. So we are going to this equation, how we got it? Now, by considering only change in temperature. That is what now? These reports supports are removed and this twisting couple is removed only like this all. This is called a free expansion. Only the student should know this equation. That's all. If you know the free expansion case, remaining simply what now? Subject is the thermal application of whatever you have studied now. What the condition for thermal stress? What the condition for thermal stress? There should be a change in temperature. Change in temperature. And due to the change in temperature, what happens now? Due to the change in temperature, thermal deformation will occur now. Either increase in length or decrease in length. If the temperature increase in length. That is called as expansion. If the temperature decrease, contraction. And what the second condition now? Thermal deformation should be restricted either thermal deformation should be restricted either completely or partially. But if only first condition is there, what now? It is called a free expansion or free deformation, then thermal stress 0. If only first condition is satisfied, if only is 0, when only first condition is satisfied. एक बार देखो सोमनाथ मंडल जी, दिस इज MDET 4 इज व्हाट ना एज पर MSST. शायद अभी तक आपने टेबलर फॉर्म नहीं देखा था. मैं कल ही बोला था, आज क्लास आने के पहले एक बार वो टेबल देखने के लिए बोला था. 4 is only for MSST. I use the MDT. I used it here now. We don't have a time now to refer what now. Go through the table now. थोड़ा टाइम लगा वो, थोड़ा टाइम देख के वो टेबल एक बार देख लीजिए. आपके पास टेबल है, एक बार देख लीजिए. आपको morning whatever I written what now by using MSST, but this is MDET. Because of Thermal stress 0 when only first condition is satisfied. देखा क्या सोमनाथ जी? Free thermal deformation of a rectangular block. So this example is what now? I consider what now? This example only. My hand is a flat surface. And this one a rectangular block. Duster is a rectangular block. Kept it. And this heated uniformly. Uniformly heated means what? At each and every cross section change in temperature is same. At each and every cross section change in temperature is same. In this case, length will increase, height will increase, width will increase. So here only you have to write down the equation for change in length, change in height, change in width, thermal strain and volumetric strain. You have to write down now. Is the initial one. Now I am showing the deformed shape of the block. I am assuming the temperature is increased. What is the alpha? Alpha is the linear coefficient of thermal expansion. Alpha is the linear coefficient of thermal expansion. This is the deformed shape of the block. Due to temperature rise. I'm showing the little bit of larger dimension, change in dimension, but the change in dimensions are very, very small, especially in the elastic region. Length will increase. Alpha is the linear coefficient of thermal expansion. So here there is no stress. Here thermal deformation x direction means change in length, which is equal to L1 minus L, which is equal to alpha T. As per my notation, T the change in temperature. T is not a temperature. If the temperature constant, there will not be any deformation. Therefore, as per my notation, wherever I am T in writing means what T I am writing means is a change in temperature. Actually, I write down the delta T, but I am writing T. So this is about a change in what this C now. The C value depend upon the temperature variation. C is equal to 1, 2, 3, 4. 1 is for what now? Uniform temperature variation. For the meaning of just now I discussed uniform temperature variation. Means temperature variation diagram is a rectangle. At this end change in temperature T degree centigrade. Here also T. Means at each and every cross section change in temperature is same. Then it is called a uniform temperature variation. What is the meaning of uniform temperature variation? At each and every cross section change in temperature same. The temperature variation diagram is a rectangle. Then at that time C is equal to 1. So most of the textbook they are giving all Indian author textbook is a uniform temperature variation. But only in foreign author textbooks and made in the test series they are giving change in temperature, this end is 0. Here this end, right side change in temperature is T. Here change in temperature is 0. But this side change in temperature T. And the change in temperature is what now? Varying linearly. That is called what now? LTV. Linear temperature variation means the temperature variation diagram is a triangle. What the ALD, SFD, BMD, TMD are discussing now? How axial load, shear force, bendmeter and twistement are varying from cross section to cross section. Now what the temperature variation diagram? The temperature variation diagram is the temperature variation diagram. How change in temperature varying from cross section to cross section. If the temperature variation diagram is a rectangle means at each and every cross section change in temperature is same. This is called a UTV. Default you have to take a UTV. Sometimes they are calling it what now? Change in temperature is a function of X. It's a linear temperature LTV. What the meaning of LTV now? This and change in temperature 0. This and change in temperature is 100 degrees centigrade. But cross section to cross section, the change in temperature is varying linearly. Here 0, here 100. And here to here what? The change in temperature is what now? Varying linearly. Then LTV. Next PTV. PTV means what? A parabolic. PTV means parabolic. Here change in temperature 0, here change in temperature T, and here to here change in temperature varying parabolically. Means temperature is what? A change in temperature function of x square. Parabolic temperature variation. Then cubic parabolic temperature variation, CPTV, cubic parabolic temperature variation means the change in temperature function of x cube. So C value depend upon the temperature variation. If nothing is given, C equal to 1. That is what now? Uniform temperature, means temperature variation diagram is a rectangle. But somebody will ask, sir, how you got the equation? Take a small strip at a distance of x, just like how you got the change in length now in a tapered bar. Take a small strip at a distance of x. The change in length of the strip is dx. Then here change in temperature Txx. Change in temperature is what? A Txx. So what the change in length here now? Change in length is what? Alpha into the length of the strip is dx. Txx is what? A change in temperature at their cross section. Alpha is the what now? Coefficient of thermal expansion. Alpha xx. Now you have to integrate this now. If change in temperature is constant, what the meaning of this now? If it is made of same material, alpha is constant. And if everywhere the change in temperature is same, T is also constant. So you can take the alpha into T outside. So what the dx integration between 0 to L, alpha TL. So C is equal to 1. Suppose the change in temperature is what? A varying linear. So what the Txx now? Txx is what now? Tx by L. The what the x integration now? X square by 2. Then you are going to get an alpha TL by 2. Generally, the bar is made of same material. Alpha is constant. What this alpha is representing now? What the alpha is representing? What the alpha terminology? Linear coefficient of thermal expansion. Linear coefficient of thermal expansion. What the alpha is representing now? Change in dimension for a unit temperature variation or a unit dimension. Alpha is representing what? Alpha terminology is what now? Linear coefficient of thermal expansion. So what the alpha is representing now? What the change in dimensions of a member for a unit degree centigrade variation or a unit dimension. Unit degree centigrade temperature variation or a unit dimension. So how to get the change in length? Now here what the change in temperature at xx, now Txx. What the length of the strip dx. So do it integration now. Suppose this Txx is a constant. This is called as what now? Uniform temperature variation. Uniform temperature variation means temperature variation diagram is a rectangle. UTV means uniform temperature variation. This is what now? At left side change in temperature 0. Right side change in temperature T. But here to here what? A varying linear. So the change in temperature is varying linearly from left to right. It is a function of x. Then it's called the LTV, linear temperature variation. Linear temperature variation. Then temperature variation diagram is a triangle. Here temperature variation diagram is a rectangle. This is what a PTV. Parabolic temperature variation means the change in temperature varying from 0 to T. Change in temperature varying from 0 to T. T the what now? Change in temperature at the right hand. T the change in temperature extreme right hand. That is the maximum change in temperature. But other end change in temperature 0. So year to year change in temperature varying parabolically. Therefore here temperature variation diagram is a parabola. The diagrams I am not drawing now. You know here what a rectangle, triangle, just like UDL, UVL like this now. ALD means what? ALD the rectangle means at every cross section axial or the constant. Temperature variation diagram rectangle means every cross section change in temperature is same. Cubic parabolic temperature variation. Cubic parabolic temperature variation. So now in this case T can be taken outside. T can be taken. But the integration of dx L, then you are going to get alpha TL. Then C is equal to 1. If you go for LTV, what the x integration x square by 2, then you are going to get alpha TL by 2. So C is equal to 2. If you go for this one, what this equation now? Alpha TL by 3. Alpha TL by 3. What the x square integration now? X cube by 3. X square integration x cube by 3. Then you are getting alpha TL by 3. And what the x cube integration x to the power of 4. So denominator you are getting 4. So C is equal to 1 for this one. What the C value now? 1. C value is 2. C is 3. C is 4. But default you have to go for this now. If nothing is mentioned, most of the problem they are mentioning uniform temperature, but students will not bother. What the meaning of uniform temperature variation means? At each and every cross section change in temperature same. Mean the temperature variation diagram is a triangle, rectangle. Here temperature variation diagram is a triangle. Is a parabolic temperature variation. And what a temperature variation diagram is a cubic parabola will be there now. Same thing. Thermal deformation in y direction. Thermal deformation y direction is delta T. Thermal deformation in z direction. So when the equations are valid, now what the assumption I made now? Alpha I taken outside the integration means it is made of same material. Next, it is valid under free expansion. So what the condition for the equation now? First of all, it should made of same material and free expansion. But most of the textbook they are going to write down like this now. Change in length is equal to alpha TL. Means C is taken as a 1. In this case, how many condition now? 3 condition. What the first condition? Prismatic, so no, not prismatic, same material, free expansion, and uniform temperature variation. Conditions are important. But here I've already taken C. So this is valid for any case. Therefore, what the condition for these three equations now? First of all, it should be a made of same material. Alpha is taken outside the integration, and free expansion case. Free expansion case. Everybody know this equation, alpha TL, they will tell it now. But what the condition now? Same material, free expansion, and uniform temperature variation. Free thermal deformation. But if I am going to write down this, and what the extra condition I had to write down now? Free thermal deformation, same material, and uniform temperature variation. Uniform temperature variation. Now can you write down the strain now? Now you tell me now. Which one is, they're all equal or unequal now? Thermal deformation in x direction is greater than z direction, because when all these thermal deformations are equal now, when all these thermal deformations equal, length, width, and thickness should be same, only in case of cube. In case of cube, thermal deformation, all the three directions are equal and like in nature. But here, in case of rectangular case, what happens now? They are unequal but like in nature. Unequal like in nature. So thermal deformations always what now? In three mutual perpendicular directions. Like in nature but equal or unequal, depend upon the cross-sectional dimensions. If length, width, and thickness are equal, it is a cube. Then at that time, it is only in case of cube. Only in case of cube, thermal deformations equal and like in nature. But in case of rectangular block, they are unequal but like in nature. Unequal like in nature. In case of cube, so what the conclusion I made now? Thermal deformations in three perpendicular directions are like in nature, but may be equal or may be unequal. Only in case of cube, they are equal and like in nature. In rectangular block, unequal and like in nature. Next, what is the very important conclusion now? This deformation depend upon only dimension the x direction. What the dimension x direction? L. Means this deformation independent of the width and thickness. This deformation depend upon only dimension the direction. But what about the mechanical deformation? If I am going to pull a bar, what happens now? If I am going to pull a bar, what the change in length of the bar now? 4PL by pi d square E. If I am going to pull a rectangular bar, if the same bar is going to be pulled, what the change in length now? PL by B into D into E. Means change in length depend upon only length or width and depth also. So mechanical deformation not only depend upon the dimension in that direction, but also depend upon the dimension in other direction. But here thermal deformation depend upon only dimension in the direction. It is independent of the dimension in other two direction. You have to make a comparison between what now? Thermal and mechanical deformation. Thermal and mechanical deformation. But what about the mechanical deformations? Always unequal, unlike. When a bar is going to be pulled, length will increase, width and depth are going to be decreased. They are unequal, unlike. But here, like in nature. When a bar is pulled, if the rectangular bar is pulled, length increase, width and depth are decreases. Those strains are called a longitudinal lateral strain. But in this case, what is the longitudinal strain, lateral strain? Zero. There is no longitudinal strain and lateral strain. So you write down this now. Thermal deformation in any direction depend upon only dimension in the direction. Depend upon how many parameters now? 3 parameters. One is the material property, change in temperature, and dimension in the direction. It is independent of the dimension in other two directions. Now can you write down the strain now? How to write down the strain now? Change in dimension in the direction upon original dimension. So it will be alpha T by C. T is the what now? As per my notation, once again I mentioned T the change in temperature. But is it a strain in X direction or Y direction or Z direction? All are same. Similarly, want to get a strain in Y direction, this should be divided by small t. Then you are getting alpha T by C. Alpha T by C. So what is the conclusion now? Thermal deformations may be equal, may be unequal. But thermal strains are always equal and like in nature. Thermal deformations are what now? Like in nature, but may be equal or may be unequal. But in rectangular block, they are unequal but like in nature. But what about the thermal strains? Equal and like in nature. In all the direction, strain is same. And all the direction, it is like in nature. But what about the mechanical strains? Unequal, unlike in nature. You can call the directly thermal strain equal to is a positive or negative, is a tensile or compressive. If the change in temperature is what? A positive. If the temperature increases, a tensile. If the temperature decreases, going to be a compressive. Just now taken for only temperature rise. Even compressive also like same now. So when should I use the plus now? Plus should be used what? When temperature increases. Minus should be what now? Temperature decreases. So thermal strain the tensile or compressive. When temperature increase the tensile, temperature decrease the compressive. Thermal strain in three mutual perpendicular directions are equal and like in nature. But what about the mechanical strain now? Unequal, unlike. Longitudinal strain, lateral strain, never they are equal and never they are like in nature, but they are unlike. Unequal, unlike. But here they are equal and like in nature. In this case, what are the longitudinal strain, lateral strains? Longitudinal lateral strains are 0. When you are going to get a longitudinal strain, lateral strain, when there is a load, here there is no load, longitudinal strain, lateral strains are 0. So what is the thermal stress now? Zero, because whenever you want to get a stress in any direction, load is required. Since there is no load, there is no stress. But some students are going to write down like this now. Sir, Young's modulus equal to sigma by epsilon. So sigma is equal to E into epsilon. Sir, thermal stress and normal stress. You have mentioned thermal stress and normal stress. Then E into thermal strain. So from this one, sir, it is alpha delta E by C. Sir, in all the textbook they are written the thermal stress alpha delta T, sir, but you have written 0. Thermal stress 0 or non-zero? 0, because of there is no load. When there is no load, no stress. But when you are going for interview, they will try to confuse you now. Young's modulus equal to sigma by epsilon. So sigma equal to E into epsilon. Since the thermal stress and normal stress. Thermal stress and normal stress. Then you have to take the what now? Thermal stress equal to E into thermal strain. E into thermal strain. And thermal strain, how much you got it? Alpha T by C. Sir, alpha T by C. Previously you have given 0. But if I go for this one, alpha T by C. Use any method, you should get the same answer. But why I am not getting 0 here now? Not a single student will answer it now. Why I am getting, actual stress should be 0, but I am getting alpha T by C. In all the textbook they are going to write down like this now. Is a blunder. What the Young's modulus definition of sigma by longitudinal strain? Sigma by longitudinal strain. So here what should I take in a longitudinal strain? What the longitudinal strain? 0. Stress is 0. So thermal stress does not depend upon the thermal strain. Thermal stress depend upon the longitudinal strain. Is a blunder. What should I write down now? What the definition of Young's modulus here studied? Sigma by longitudinal strain. So sigma is equal to E into longitudinal strain. So thermal stress is equal to E into longitudinal strain. What the longitudinal strain? 0. What the longitudinal strain? A normal strain in the direction of the load. When there is no load, no longitudinal strain, no lateral strain. So what is the very important conclusion now? Thermal stress does not depend upon the thermal strain. Thermal stress depend upon the longitudinal strain. This is a very, very important. Most of the low standard textbooks, they will write down like this now. Thermal stress equal to E into thermal strain. Thermal stress does not depend upon the thermal strain. And most of the faculty who is teaching all the subjects now. All the subject, production, thermal, design, electronics, electrical also they will teach it now. And they don't have the time now. And they will refer the some of the textbooks. And they are going to put it, because some textbook they are writing like this, he is going to reproduce it. And they are going to assume he is a very famous teacher in the production, and he is going to assume he is also very famous in the strengthometer also. Is a very famous in what? Strength of production. No? Is not very famous in what? Production strength of material. No? And we are going to believe him. No? Try to learn the what? No? Concept from a right person who is specialist in that. No? I mean, I can what teach the thermal, I can teach the what now? Theory of machine, but I'm not perfect now. Now, day after tomorrow, another teacher is there. He's a specialist in the theory of machines now. That is the specialty of the what made is he now. Simply taking the whatever is there available in the textbook, they are going to reproduce it now. And we are going to believe the teacher. So this is about a very, very important now. Very, very important. Thermal stress does not depend upon the thermal strain. Thermal stress depends upon the Longirus strain. Then what about the volumetric strain? Plus or minus 3 alpha T by C. Plus or minus 3 alpha T by C. Once again, when should I the plus now? When temperature increase. When temperature decrease is going to be compressive. But some students will write down what now? Sir, 1 minus 2 mu by into sigma x plus sigma y plus sigma z, sir. If I that use the equation, sir, volumetric strain equal to 1 minus 2 mu by E, sigma x plus sigma y plus sigma z, sir. Sigma x, sigma y, sigma z is 0, sir. So volumetric strain 0, sir. That equation is valid when only loads are acting. But the equation what you have studied now, it is a generalized. This is valid what you have studied now. Even load is acting or even in the absence of the load. Here change in volume is due to load or due to change in temperature? Due to change in temperature. But the equation valid for what now? How we got the equation mathematically got it now? So this is what now? Even when the load is acting or even in the absence of the load. That even temperature variation also valid now. But that 1 minus 2 mu by into sigma x plus sigma y plus sigma z, that is valid only when the loads are acting. Here we cannot use that now because there is no load. When there is no load, no stress now. When temperature increases, or tensile in nature, and vice versa. Vice versa. When temperature decrease, both are going to be compressive in nature. A cube of side 1 centimeter whose temperature increased by 1 degree centigrade. So what is the change in volume? It's a simple objective question now. Change in temperature is 1 degree, side is 1. So default, if nothing is mentioned, see the uniform temperature, C is equal to 1. If nothing is mentioned, we are taking the C is equal to 1. Default C is 1. That is the uniform temperature. Therefore, directly delta V is what now? 3 alpha cubic centimeter. 3 alpha cubic centimeters. Now, here stress is 0. But for me, strain is also should be 0. Even if temperature increases, stress should be 0, strain should be 0. Means change in dimensions also should be 0. Is a general standard interview question will be there now. When temperature increases, to maintain dimensional stability, temperature increase, dimension will change. But for me, dimension should remain same. If the dimension should remain same in what now? Deformation should be 0. When the deformation 0, strain is 0, stress 0. In this case, are you getting about now? Stress is 0, but strains are there because change in dimensions are there. So to maintain dimensional stability, even if temperature increase, length, width and thickness should be same. What the answer now? Change in length should be 0. That is what the change in length here right now? Alpha TL upon C. So the change in length should be there, means alpha should be 0. Means you have to select a material with a 0 coefficient of thermal expansion. But there is no material with a 0 coefficient of thermal expansion. Probably you might have studied the material science now. Out of all the material, only one material is what? Invar. Steel and nickel alloy. Steel and nickel alloy. Which will have the what now? Negligible coefficient of thermal expansion. Alpha is not 0, but almost equal to 0. So whenever you want to get a dimensional stability in presence of change in temperature, we have to select a material with 0 alpha. That is what Invar is selected. That is a nickel alon steel alloy. To maintain dimensional stability, in presence of Invar, that is steel and nickel alloy. Nickel alloy. Should be selected. Selected as the material of that component. Material of that component. Alpha of invar. (1.2 into 10 to the power of minus 6). But if you go for a steel, how much you are going to get? 12 you are going to get it. So these alpha values I'm writing, you need not remember. They're all going to be given as the input data, but you should know which out of the two material, which one is the higher alpha, which one is the lower alpha is required. When compared to invar, diamond alpha is going to be less. Next, steel 10 times more, 10 times of invar will be there now, and copper alpha is more than steel. Copper will be 16 into 10 power minus 6. You need not remember, but you should know composite bars are given. A composite bar, a copper and steel bar assembly. If the temperature increase, which stress is developed now? There you should know which is the higher alpha and which is the lower alpha. Brass and bronze. Is 20 into 10 power minus 6. Then aluminium. (23 into 10 power minus 6). So this is a clear, that's all. Remaining is what? A simply application of free expansion and what you have studied, that's all. Case 2. Completely restricted deformation. Now student who is thorough with the what now? Whatever is thorough up to now what I taught it now. Then he can do remaining question by using this now. Remaining all are simply application of what the concept you have studied and this now. That's all. So already explained this now. Now if I'm going to remove these two support, it's a free expansion. But reactions are 0 or non-zero? Non-zero. When the temperature increase, what happened? This end of the bar, what now? This right side what will tries to expand towards right side. So what the action of the bar? What the action of the bar on the right side? It will what now? Expand like this now. So what the action of the bar onto the support now? It will push this support towards right side. So what the action of the bar now? Towards right side. Then the support will offer a reaction towards left side. Means that will become as a compressive load. Next, this side what happens now? It will expand, bar will what? Expand towards left side. So what the action of the bar onto the support towards left side. Then support will offer a reaction towards right side. But both the reactions are equal. Why now? For equilibrium condition, what you have studied now? When net axial load is 0. When net axial load is 0, reactions are equal and opposite. Here no axial load on the bar now. When net axial load is 0, reactions are equal and opposite. So directly what you have to do it now? Superposition. First you remove this supports. If you remove this supports, what the change in length? Just now you discussed now. Alpha delta TL upon C. Alpha TL by C. Next, assume only reactions are there. If I am going to remove the change in temperature, this will become a pure axial load. Pure axial load. So what the stress due to axial load now? Or what the change in length due to axial load? PL by AE. Just now you have done it now. So what this figure representing now? A prismatic bar held between two supports. PB, prismatic bar held between two rigid support. For the compatibility equation, I have to take it now. Change in length of the bar. How many change in lengths are there now? Superposition. Due to change in temperature, thermal. And due to reaction, axial. Should be 0. So when the equation valid, now free expansion means I am assuming what now? I am assuming initially there is no supports. When there is no support, what the change in length? Now alpha TL by C. Next, assume only reactions are there. When reactions are acting, this strain is about now longer strain. What the change in length? Now PL by AE. But what the P value now? Minus R. L by AE. This is nothing but axial stress only. Actual term should be what now? Axial stress only can call it. But in place of the axial stress, you are calling it as thermal stress. Why now? Because these reactions are developed due to change in temperature. If the change in temperature 0, reactions are 0. It is nothing but axial stress only. But in place of axial stress, you are calling it thermal stress because these reactions are developed because of the change in temperature. So from this one, alpha T alpha T by C. Now I want to get the reaction. How to get the reaction now? Here how many conditions now for this equation now? How many conditions here now? How many conditions now? First of all, it should be a prismatic. Next, same material. And completely restricted deformation. Completely restricted deformation. But if all the textbook they are writing alpha T only, then at that time what the extra condition I have to write down? No? If I remove this C, I have to write down the extra condition is what a uniform temperature variation. All the textbook they are writing alpha TE. Then in that case, what the one more condition? No? Alpha TE means valid about a prismatic bar, same material, completely restricted and uniform temperature variation. But this is a compressive or tensile in nature. If it is going to be tensile, sir. Already you have taken compressive load only. Under compressive load, you are going to get a compressive stress. But I am getting a positive. But I already have taken negative only here now. Since I have taken negative, I am getting positive, I am getting now. So this is a compressive or tensile now. Compressive. But if temperature increases, it is a compressive. But temperature decreases, what happens now? It is a tensile will be there now. Temperature decreases, it is a tensile will be there now. Now can you write down the Longitus strain? Can you write down the Longitus strain? What the other way of getting this equation now? Instead of this one, if I want to get the directly thermal stress, it is what type of state of stress you are getting now? Uniaxial state of stress. Anybody vote now? For this case, what the maximum tensile, maximum compressive, maximum shear stress now? Maximum compressive stress how much now? Alpha TE by C. Maximum tensile stress 0. But what the maximum shear stress now? Under uniaxial state of stress, what the maximum shear stress now? Half of this now. It is a uniaxial where you are going to get maximum shear stress on Tomax planes at the diagonals. In one of the test series paper now is given what the maximum shear stress in the bar. Sir, you mentioned thermal stress there. Thermal stress and normal stress you have studied, sir. But there are the shear stress, sir. So answer should be 0, sir. Either Medici team has given the incorrect answer or you are taught the wrong concept. But we are always correct. Sir, how shear stress is non-zero, sir? You have mentioned thermal stress. Whatever you have studied on the cross section, you have studied. See it what? These are all what on the cross section only. On the cross section, shear stress 0. We are adding the thermal stress to what axial, bending, torsional shear, direct shear. They are all on the cross section. So if we ask on the cross section, shear stress 0. But if we ask in the bar, what the answer now? Half of this now. So what the for this question now? What the maximum tensile stress in the bar? Zero. What the maximum compressive stress? This is a cross section. Then all are simple concept now. But what is the shear stress on the cross section? 0. So thermal stress always what on the cross section only. So you should be careful now. What the other way of getting the equation now? Total strain. Total strain can be equal to 0. Total strain which direction? Suppose I am taking the x direction. X direction. So what the total strain in x direction now? How many strains are there? Due to change in temperature, thermal strain. And due to reaction, longitudinal strain. It's going to be 0. So what the thermal strain now? What the thermal strain equation? Alpha T by C, positive or negative? When temperature increase, alpha T by C. And what the longitudinal strain? Unknown. So what the longitudinal strain now? So longitudinal strain is what now? Minus of thermal strain, means compressive or tensile, compressive. So thermal stress depend upon what now? What the Young's modulus now? You can also use this method now. This method is the better method now. This is valid for both now. Uniaxial, biaxial, triaxial, every case now. But if you go for biaxial, what happens now? If you go for biaxial, what change? How many strains are there? If you go for the uniaxial state of or biaxial, uniaxial. So how many strains are there? No, only longer strain. But if you go for biaxial and triaxial, what should I write on total strain in x direction? In triaxial, what the total strain in x direction? 1 by E sigma x minus mu sigma y plus sigma z plus thermal strain. That should be equal to 0. Now can you get the change in diameter here now? Can you get the change in diameter? How to get a change in diameter? Epsilon y is required now. How to get a change in diameter? Total strain in y or z, which is equal to delta d by d, delta d by d, which is equal to thermal strain plus lateral strain. Thermal strain all the direction equal or unequal? All the direction is equal. What the thermal strain in all the direction now? Alpha T by C. How to write on longitudinal lateral strain? Lateral strain is what? A minus of longitudinal strain. Minus of longitudinal strain. For the longitudinal strain, you got it now. So from this one, what the delta D? But most of students, they are going to give what now? Sir, alpha TD. But when alpha TD is valid, free expansion. Is it a free expansion? No. It is not a free expansion. Most of the, if I ask this question in all the batches now, what the change in diameter? 50% of students are alpha TD, sir, 2 alpha TD, sir, mu alpha TD. They are going to give it. What the answer now? Alpha TD by C into 1 plus mu. My dear friend, please try to have some patience. Let me complete today. Generally, we are extending up to 5:40. So let me complete. Mostly, I'm going to complete 6 o'clock. But with this one, you can do it. But let me complete some questions. Give me what now? Maybe it is difficult, but what now? Try to have a patience. So many times, so many days, you have cooperated with me. 15-20 minutes more than last 3 days. I'm forced to sit for last 3 days, 2 hours more than the allotted time now. But Medici team has informed me that I have to complete the syllabus on Monday, Tuesday onwards, new subject is started. But students suddenly today what are there is no class tomorrow now. If they inform me initially itself, we can extend the class up to Tuesday. I may not have forced you to sit so many hours now. Every day you are taking the 2 hours more now. 4 hours, 4 into 2, 8 hours, that can be almost complete tomorrow itself now. They asked me to complete tomorrow, it's a Monday, is the last class, they mean. But suddenly when I have seen your, tomorrow there is no class work. So if they have informed me, you can also take the class up to Tuesday. I may not have forced you to sit 8 hours or like this, 8.5 hours now. Now is a tensile or compressive? Tensile. Is a positive or negative? Positive. Diameter will increase. But everybody is going to give what now? All the students in every batch, 90%. What the change in diameter? Sir, alpha TD, sir. Mu alpha TD, sir. 2 alpha TD, sir. They will leave the basics. They leave the basics. They know everything, but they will not believe themselves now. I'm not telling what they don't have the talent now. They're having a talent, but they want to give the ready-made answer now. You are not playing a lottery game. You are not playing a lottery game. You are playing a game of your future. Game of your future. If you know 100% answer, if you already solved that question during your practice, already know the answer 100%, then you give the answer directly. But whenever you are come across any question for first time, don't depend on your luck. Depend upon your concept. You are about now. Once you attended my lecture means definitely your concepts are clear. Suppose next time this question is asked, you know the answer, you can directly give it now. But whenever you are trying any question for first time, please don't try to check your luck. Don't depend upon your luck. Remember what now, you are not playing your lottery game. You are playing a game of your future. That 1 mark makes a lot of difference now. You know everything. If you don't know everything, you can go to play a lottery game now. But you know everything, why you have to play a lottery game now? Sir, A is correct, sir, B is correct, C is correct, without knowing the answer now. If you already know the answer, then you can directly tell it. If you have come across a question during exam that you already solved during your class, you know the answer 100% now, then you directly select the answer. But whenever you have come across any question for first time, please don't depend on your luck. Depend on your concepts. You are a unique person, you know everything. Don't underestimate yourself. So what the conclusion you can make it now? When temperature increases, what the answer now? Thermal strain is a tensile or compressive? Thermal strain is tensile in nature. And longitudinal strain is always thermal strain and longitudinal strain unlike in nature. When thermal strain is a tensile means longitudinal strain is compressive. And thermal stress is compressive in nature. Vice versa. When temperature decreases, what the dimensions are decreased. When temperature decreases, dimension will decrease. So thermal strain is a compressive, longitudinal strain is a tensile. Then thermal stress is what? Tensile. So always what now? Thermal stress depend upon the longitudinal strain. When temperature decreases, thermal strain is compressive. Longitudinal strain is tensile in nature. And thermal stress is tensile in nature. But here only what the assumption I made it in this case now. Buckling you are neglected. This looks like a column. Columns are subject to axial compression. Buckling is neglected means we are assuming somebody will ask now, why does it look like a column? Why you are neglecting the buckling? What the answer now? It is assumed as a short column. Only buckling will get it. Long columns is more. Short columns is going to be neglected. Short columns are going to be neglected. And the third one is what now? Partially restricted. Partially restricted deformation in one direction. Partially restricted deformation in one direction. So this is a partially. Anybody what? This is what now? Is it a partially or free expansion? We don't know. Everybody is going to tell sir partially restricted. When the partially restricted, reaction should be non-zero. Yesterday I studied this example. When the partially restricted, when change in length is more than lambda. Lambda is the gap between the bar and support. So when this change in length of the bar is more than the lambda, then reaction will be developed. Then it is partially restricted. But if the change in length of the bar is less than lambda, is a free expansion. But if you ask everybody is what now? Sir, the partially restricted. Clearly yesterday mentioned now. Partially restricted means there should be a reaction should be there now. When the reaction is developed now, when the change in length more than lambda. But I've already mentioned what a partially restricted. Here I already mentioned partially restricted means what the assumption you are making now. Suppose if this condition is not mentioned now, simply this is question is given. Stress is 0 or non-zero. Sir, maybe 0 or may not be 0. Suppose the change in length of the bar is what? Less than the lambda. Is a free expansion. Assume this is 10 mm, this length, change in length of the bar is 8 mm. Due to change in temperature, length will increase. But the increase in length is less than the lambda. Is a free expansion, then stress is 0. But if the change in length of the bar is more than the lambda, then at that time what is the partially restricted? But since I have already assumed the partially restricted, means what the assumption I am making here now? Mean what the assumption I am making now? Thermal deformation is what the lambda is representing a gap between the bar and support, gap and bar and support. Here what change I have to make it now? In this case what the compatibility equation? Change in length is 0. Here what the change in length? Lambda. So here reactions are thermal plus axial deformation. 0 or non-zero? Change in length of the bar is 0 or non-zero? Change in length of the bar is non-zero. How much change in length is possible? Change in length is possible equal to lambda. How much change in length is permitted? Lambda. So what the lambda is representing? Gap between the bar and support or change in length of the bar. So now you can write down now what the thermal deformation. What the axial deformation? Once again, what this R by A? R by A. So from this one, sir, can you use the second method? You can use it. What is the second method I had to write down now? Total strain equal to what now? Longitudinal strain plus thermal strain equal to what now? In the previous case you are equal to 0. But what is the total strain here now? Lambda by L. What is the total strain? Lambda by L. In this case, once again you can use the second method. What is the second method I had to write down now? Total strain in x direction equal to longitudinal strain plus thermal strain equal to lambda by L. I have to do it now. You can use it now. Now, what is the condition for this equation now? What is the condition for this equation? Prismatic bar if I remove the C, then I have to write down UTV. But everybody is going to mention, sir, it's for completely. Is it valid for any case? Is it valid for completely restricted or partially restricted or free expansion? All the case. Is a generalized case. This is valid for case 1, case 2, case 3. For completely restricted, what is the lambda value? Try to understand what this lambda, change in length of the bar. In case of completely restricted, in this case, what is the lambda value? No, 0. In this case, lambda is 0. So if I put it lambda equal to 0, are getting the same equation, or you can check it now. If I put it lambda equal to 0, what you are getting now? Alpha T by C. Lambda is what? A change in length of the bar. In the case 2, what the change in length of the bar? 0. If I put the lambda equal to 0, check it, you are getting alpha t by c. For free expansion, what the change in length of the bar? Free expansion, change in length of the bar is what now? Alpha TL by c. In free expansion, how much change in length is possible now? Alpha TL by c, then 0. But if you ask the most of student what the another condition, sir, is valid for third condition, partially, this is valid for partially restricted, free as well as what now? Completely restricted. Lambda is 0 for first try to write down the lambda. Lambda is what now? Lambda is my notation. Gap between bar and support. Change in length of the bar. Change in length of the bar. Next. Spring deformation. Suppose in between this a spring is provided, so that lambda is nothing but about a spring deformation. And gap between rails and rails, gap between two adjacent rails, gap between two rails. Railway track rails, now gap is provided to avoid the thermal stress now. Adjacent rails or yielding of the supports. Yielding of the supports. And lambda is equal to 0 for completely restricted. And lambda is equal to alpha TL by C for free deformation. So this is valid for any case, is valid now. It is valid for any case. Now can you get the once again change in diameter? Same concept now. If you divide by what now? If you divide by Young's modulus, what will get it now? Longirus strain. If you divide by Young's modulus, you are going to get a Longirus strain. Then you will get a lateral strain. How to get a lateral strain? Minus of mu multiplied by Longirus strain. So once again, you can use the same concept for change in diameter. How to write down the change in diameter now? Total strain in y direction. How to write down the total strain in y direction? Thermal strain plus lateral strain. How to write down the lateral strain? Minus of mu multiplied by Longirus strain. How to get a Longirus strain? Divide by Young's modulus. If you divide by the Young's modulus, you are going to get a Longirus strain. So now you can do all these questions like this now. If this question is given, can you do it now? This is nothing but what? A bars in series. Just now you done for one bar. What you had written? Delta L1 plus delta L2 0. Bars in series. What the delta L1? Thermal strain plus Longirus strain. Or you can use about the same concept. This comes under what? The bars in series. Two bars are there. First bar and second bar. 0. What is the change in length of the bar now? Thermal plus just now you have done it for one bar. There are two bars in series. Compatibility equation. When only one bar, what you have done it, directly equated the change in length bar 0. But there are two bars are there. So delta L1 plus delta L2 should be 0. Same concept should be used it now. So I'll take the one last important question. So like this what I can do any of the questions. This question whatever I'm going to discuss repeated so many times. Both engineering service and the gate paper now. Initially, this question was given in the engineering service paper 2003. But afterwards, the same question was repeated 3 times in the gate examination now. Very few times engineering service questions are given in gate papers now. Some of the engineering service questions also typical questions are there. Some students are asking, sir, I am preparing for gate now. Shall I do the practice of engineering? So definitely practice the questions now. But practice the question with your calculators now. Virtual calculators. A cube is restricted in all the 3 directions. A cube is restricted in all the 3 directions. So stresses develop in all the 3 directions. How many faces will be there? 6 faces. Left side face, right face, top, bottom, front and back. It is restricted in all the 3 directions. So reactions are developed in 3 directions. Reactions in all the 3 directions. Reactions are same because of cube now. Reactions are same because of the cube. So for the rectangular block, reactions are different. Why now? Thermal deformation, all the directions are equal. Therefore, reactions are same. But if you go given as about a rectangular block, reactions are unequal. If a rectangular block is given, reactions are unequal. But here, reactions are same because of the what? A cube. Thermal deformation, all the directions are same. So what should I write down now? Rx, Ry, Rz equal to minus R. Areas are equal. So stress in all the directions are same. So temperature is increased. Temperature is increased. So this question can be done by the 2 ways. When a bar is restricted, what you have done it now? When a bar is restricted, what you have done it? Equated the change in length to 0. But here change in length 0 or change in dimension 0 or change in volume is 0, both are 0. Change in dimension 0, change in volume is 0. When a bar is restricted one direction, only change in length is 0, but change in volume is not 0. But here change in volume is 0. So what the one method you can do it now? change in volume should be 0. Change in volume should be 0. Here what type of state of stress is there now? State of stress about hydrostatic. Here what the state of stress is there now? Hydrostatic. Hydrostatic state of stress is there. Now what this change in volume due to temperature? This is due to temperature. This is due to reactions. How to find out the change in volume due to change in temperature? Volumetric strain. In place of take the directly volumetric strain, you take it. In place of change in volume, take the volumetric strain. What the volumetric strain due to change in temperature? Superposition. Due to change in temperature, first remove all this reaction. Only change in temperature. What the volumetric strain due to change in temperature? Alpha T. Default I am taking the C is equal to 1 I am taking now. In the question is mentioned uniform temperature variation. And what about the volumetric strain? Volumetric strain due to this reaction, you can use the bulk modulus concept. Under bulk modulus, what the bulk modulus here written now? Sigma by epsilon V. This is due to what? A change in temperature. This is due to reaction. But due to reaction, you are getting a hydrostatic state of stress. So what the bulk modulus here written? Sigma by epsilon V. So what the epsilon V? Sigma by K. But sigma is what now? Negative or positive now? Sigma is negative by K. So what the sigma now? 3 alpha Tk. That's all. Hydrostatic state of stress. But in the question, one paper is asked in terms of bulk modulus is asked. That is the question is given in the workbook in terms of the bulk modulus. But in previous paper they asked in terms of Young's modulus. In terms of Young's modulus, 3 alpha T. What the K expression now? E by 3, 1 minus 2 mu. So what the expression now? Alpha T upon 1 minus 2 mu. Compressive. Both are correct. So this is easy to remember. K is equal to what? Alpha E by 3 into 1 minus 2 mu. Is the one method. What the other method now? What is the other method now? Strain in all the directions 0 or not? Epsilon x 0 or epsilon y 0 or epsilon z 0. Strain in all the directions are 0. Total strain in all the directions are 0. Total strain in x, y, z direction are 0. Total strain in all that. Change in volume is 0 or change in dimensions are 0. Both are 0. That's why I use the change in volume. And what about the change in dimension 0? Therefore, total strain in x direction. How to write down the total strain in x direction now? 1 by E sigma x minus mu sigma y plus sigma z plus thermal strain. This is already written when you have said the volumetric strain, thermal strain. Now, but see what the sigma x, sigma y, sigma z equal. Then what you are getting now? 1 by E minus sigma is a minus 2 sigma. And what the thermal strain? Thermal strain is alpha T, plus alpha T or minus alpha T. Temperature increase alpha T, 0. So from this one, once again you check it now. But which method is the better now? This is the best method. This method is valid only when restricted in 3 direction. When restricted, but this is valid what now? When restricted in 1 direction or 2 direction or 3 direction. That's why this is the best method. But in all the textbook they are doing like this now. But in exam they make you what now? Restricted only 2 direction, where you cannot use it now. Change in volume is 0 only when restricted in 3 direction. So this method is valid only when now. Valid when restricted in restricted in 3 directions only. This method already are used now. Even when restricted in 1 direction also used now. So this method is the best method now. This method is the best method. Second method is the best. Because it is valid when thermal deformation is restricted either in 1 or 2 or 3 directions. Three directions. If it's restricted in only 1 direction, which is 0. If restricted in only 1 direction means uniaxial, sigma y and sigma z 0. If restricted in 2 direction, which is 0, sigma z is 0. When restricted in only 1 direction, uniaxial means which one I have to make it 0 now? Sigma y and sigma z 0. That already I done it now. But if restricted in the 2 direction, which is 0 now, sigma z 0. If restricted in all the direction, all are non-zero. Here, which is 0 now. When restricted in 1 direction, which is 0 now. But in all the textbook, they are going to use this method now. But this will take the less time. And what the advantage now? It is valid for any case now. When restricted 1 or 2 or 3. Most of students what now? Sir, in made the test series, when during COVID period, made the what now? Telegram channel was there now. At that time, so many students are asked now, sir, in the question you had done it for restricted 3 directions, sir, but are solving the questions from Timoshenko and Gere or test series, they have given 2 directions. You can use this method now. This method is the best now. But this method is valid only in 3 directions. Change in volume is 0 only when restricted in all the 3 directions. Getting the answer is not a criterion. Getting the answer is not a criterion. Getting the correct answer within less time, and that method should be valid for all the case. So this is the best method now. But you see all the teachers and all the solution, this one will be given. If this is given, you can do it. But when restricted in 2 direction, you cannot use this method now. So that's why this I have given the best method now. I've also used this method when restricted in 1 direction. When restricted in 1 direction, which is 0, sigma y and sigma z 0. Restricted in 2 direction, which is 0, no, sigma z 0. Sigma z 0. So this complete the total syllabus is completed, but small portions are pending. For GATE students, one topic is shear center. For GATE students, I'm talking about those who are preparing only for GATE, shear center. It is a 1 hour lecture. The recorded lecture will be uploaded tomorrow, day after tomorrow. But 99% there is no possibility of any question. That is the important for civil engineering. And 2021 there is no question. 2022 there is no question. And those who are preparing for ESC can leave the shear center. Next, GATE students are left the two topics. One is shear center and columns. Columns today itself is uploaded. Columns is simple one. Today itself the lecture is uploaded. It will take 1 hour. Actually I want to discuss the columns, but here my presence is required. This is what now? Columns are what now? Easy now for mechanical. Total columns are not there. Only Euler formula is there. In your syllabus you are having only Euler formula. That's why it will take 1.5 hour lecture that is uploaded today itself. By this time, if you can check your app, it might have already uploaded. I've already instructed them to upload in the afternoon itself columns now. So for GATE students, I completed all, only 2 topics, shear center and columns will be uploaded today itself. You can go through. Tomorrow you are having fortunately tomorrow there is no class work. So you can utilize this time. Please don't relax this. Day after tomorrow onwards, one more important subject, theory of machines is there. So in the entire mechanical, these are the 2 important subjects and weightage is more. So once you start from day after tomorrow, once again you don't have the time for revise this now. So please don't relax tomorrow. Try to complete tomorrow utilize this time. Tomorrow utilize this time. I was worried about, suppose tomorrow itself your theory of machines is started. I was worried about how the students are able to do the questions of all this thing now. Because 8 hours of class, 9 hours today almost is 9 hours of class is there. How the students are able to do it. But fortunately, you don't have class tomorrow. You can utilize the time. And for ESC students, thick pressure vessels and columns are not there. For thick ESC student, only one topic is pending. That is thick pressure vessels. For ESC student, there is no columns, there is no shear center. So the shear center, ESC student has to go through the water. Those who are preparing for only ESC, they should go through only thick pressure vessels. And for GATE students, 2 lectures, 2 topics. Shear center is a simple one, but for that one, you need a shear stress the beam. 99% there will not be any question. Maybe question will be there, only objective question. So whatever I have lecture already recorded, that will be uploaded. But all the batches I am uploading the same now. And columns in simple, only Euler formula. That also 1.5 hour. Today itself, you can go through the columns now. For ESC students, tomorrow the thick pressure vessels as well as shear center will be uploaded tomorrow. So thank you one and all. Thank you for your cooperation. I done my whatever the possible I done it. It is not possible more than this now. And somebody is reminding me, sir, moment error method, that I'm going to record it, upload it. That I have not done still recording. So moment error method, I need 1 hour lecture. But you can complete all the workbook questions are still we need the moment error method. That is my duty. I'm going to record that moment error method lecture 1 hour and questions also I'm going to do it. And what are the typical questions are there, SFD, BMD, one question is there. That also I'm going to record it, upload it. But give me some time. Tomorrow, I already occupied because I thought that tomorrow onwards other subject is there. So tomorrow I've already engaged. Tomorrow is not possible. Within 2 or 3 days, that moment error method is also uploaded. Please need not be remind me. So I've done my all what is possible. It is not possible for any of the teacher to do more than this now. I've done my level best. So believe me, believe yourself, do the right action at the right time. Complete your preparation by tomorrow itself and start practice the questions appear for the test series now. Definitely believe yourself. Only one word I can use it generally, मेहनत का फल मीठा रहता है. मेहनत का फल मीठा रहता है. You know what the meaning of this now. So try to struggle a lot. And try to give a gift to your parents in the form of your success. If you love your parents, simply what now? On Mother's Day, sending what now? Mother's Day, there is no reply, not like that now. If you love your father and mother, try to give a gift to them in the form of your success. They are struggling for your future for last 20 years now. But if you are going to tell what a single word, माँ जी मेरा सक्सेस हो गया था गेट में, मेरा सिंगल डिजिट रैंक हो गया था, पिताजी मेरा आ गया, they are going to be very, very happy. This year, what the last 3 weeks back, Medi was conducted GATE and ESC reward function for the what the toppers now. There I have seen so many students came with what their fathers and parents now. Some are highly educated, some are below average. Are there what some parents are what security people also going to be there now. Some are farmers are there. By seeing their son and daughter success, they are so much of happy. Nobody can measure their happiness. They came all the way what now? From Gujarat throughout the India came to the Delhi to attend that function now. So we are happy, they are also very, very happy. So try to keep your parents in the happiest condition. If your parents should be with you forever, keep them in the happiest condition. They will be happy if you are going to get a success. If you truly love your parents, try to give a gift to them in the form of your success. That is my suggestion. So at least what now? Try to struggle because of your parents. They are struggling for you for the last 22 years now. Struggle for your what now? 1 year. But you are not going, they are not going to enjoy the fruits of the success. You are going to enjoy the fruits of your success now. They will not enjoy, but they will happy. They will happy. So this is what now? मेहनत का फल मीठा रहता है, and try to give your what now? Parents success gift. Try to remember this now. If you can keep these two in mind now, definitely you are going to get a success. Definitely you are going to get a success. So wish you all the best. Thank you one and all. And I'm going to give them my contact number. ksirupa1@gmail.com. ksirupa1 try to indicate this one. If you don't indicate the one, my cousin is also having the same now. So many every day some of my students mails will goes to my cousin. So try to indicate numeric one. ksirupa1 is about working in the US, definitely every day what till now. Every day I will going to send the 10 mails to me. Brother, I am receiving your student mail to me now. Every day is going to forward it. If anybody is sending a mail, this one. This is the same number for WhatsApp number. And suggestion is what now? If you are sending any question, please send your solution. Sir, आपने क्लास में ऐसा बोला था, मैंने किया था. Please, I am not getting the answer. Please verify my solution. If you simply send a question, taking an image and forward it, I will not respond. Send your solution so that I will identify your mistake. Then you can learn from your mistake. If I am going to give the solution, there is no use. You have to what now? Identify the mistake where you have done it now. Analysis of failure is very, very important. But if a question what now? Suppose by chance a question that I not discussed in the class. सर ये एक क्वेश्चन का कॉन्सेप्ट आप क्लास में नहीं बताया था, मुझे आइडिया भी नहीं आ रहे, थोड़ा इसका आइडिया दीजिए बोले तो देन आई एम गोइंग टू रेस्पॉन्ड. बट द क्वेश्चन विच आर ऑलरेडी डिस्कस एक्सप्लेन्ड कॉन्सेप्ट, इफ यू सिंपली टेक ए इमेज एंड फॉरवर्ड इट, आई विल नॉट गोइंग टू रेस्पॉन्ड इट. एंड वन मोर सजेशन, आफ्टर सेंडिंग ए मैसेज, try to give some time to the teacher. You may be free. Your class is going to be over by day after tomorrow, 2 o'clock. You may be free at 3 o'clock. If you are going to send a mail, by that time teacher should be free. I may be busy with the other batch now. Other works are going to be there now. For last almost for 20 days, only 2 days I was relaxed with what now? I went to my mother at that time. But I had not taken any single personal work. Family work all are pending now. So we are going to have some works are going to be there. So, but I am going to respond it as per my convenient time. Sending the message at 3 o'clock, 4 o'clock on, sir, please try to respond. Give me sufficient time. So wish you all the best. Definitely you are going to get a success. Thank you one and all. God bless you all. Thank you.